so big that they'll haunt you, or they'll calm you. That's how you know if you gotta go and get to win and not conquer. I had to go out and get it without a sponsor. Kept it real, never crooked, yeah, that's honor. Now I can go out and get it how I want to. Hashtag blessed, I choose.
What up, YouTube, Rumble, Twitter? Thank you guys for joining us over on the Ryan Matta Show. Today is Tuesday, April 30th. It's 9:30 p.m., and I have an amazing guest for you today. We're going to talk about the physics of Bitcoin, a.k.a. the Bitcoin power laws, and I'm going to be joined by a special guest, GIOVANNI, and I want to say I'm saying that right, GIOVANNI. I wanted to say GIOVANNI at first, but I think I got that right. Make sure you guys swing over and follow him on Twitter. I've also left links to his YouTube, his Twitter. We're going to dive into the topic. This man claims that he has a theory called the Bitcoin power laws, and that he has the ability or has figured out where Bitcoin is going to go based off a system or a formula that he's created. And I'm so interested to hear more about this story. But before we dive into it, can you tell us a little bit about yourself? And did I say that right? How we're going to describe that?
Yeah, perfect. Very good. Very, very good. My background is I am an astrophysicist. I got a PhD in astrophysics, and I work in the field of gravitational waves that have this vibration in space and time. And then at a certain point in my career, I went to neuroscience. My dad died of ALS, actually the same thing that Al Finney had, the same illness, and I got shocked by that because I was relatively young, and so I kind of decided to go in a more applied field and use my skill of math and physics to understand how the body works. I ended up studying the neuroscience of sleep. In particular, it was not ALS; it was more like Alzheimer, because a lot of people have cognitive problems as they age, and sleep is a big component to that. And so I use my skill of math and physics to try to understand how the brain works during sleep. I even have a patent that allows you to basically track your own brain. And then through sounds, I can improve your deep sleep. That is where most of the memories are created during sleep. And then actually we show through different scientific studies that we can improve a cognitive performance of both young people, but the advantage is even bigger with older people. And I tell you this because it's kind of almost like the story of my life of trying to apply the same principle of physics and math in trying to understand very different things. Like I told you about these gravitational waves and the brain, and now Bitcoin. So in physics, we call them universalities. When we find a pattern that is a pattern that applies to many different systems, even if they are very, very different from each other. You will think that Bitcoin has nothing to do with the brain, but there are things that are in common because the laws that describe one system are very similar to the one that describe another one. And this is very common idea about these power laws, because power laws are one of these universalities. They come up everywhere in nature. I have some slides that I can show you at a certain point if you're interested. I can show.
Yeah,
I
absolutely.
show you.
You can share your screen
Where
with my
they come
program.
from. Yeah.
Give me 1 second. Let me get you set up here, and then I'll let you,
perfect.
take it over.
Perfect.
Yeah, whenever you're ready.
Yeah. So I'm going to try to share.
You should be able to share with
camera.
photo. Yeah, with camera
Yeah,
if you can.
with camera. And let's find the window. Okay, it's this one. All right.
Wow, man. I have so many more questions that aren't even related to Bitcoin. So,
basically, my adventure with Bitcoin was all the way to 2013 when, in fact, let's go to the start here. This is how I called it. I called it human value, hash rate, energy, time, and price, because these are the things that are essential to understand about Bitcoin, right? There is human value that goes into Bitcoin. There is a hash rate that is related to energy. Time is a very essential component to understand Bitcoin, and price, right? Price, it's also human value. The difference from many other analysts is that actually I bring this scientific understanding. And I have these pictures. Somebody made these using AI, one of my followers, and I love it because it's basically this kind of like a Renaissance man that looks at Bitcoin like if it was like, a planet or a star. And we are trying to use the same principle, right? It's almost like it feels sometimes when I talk about this stuff, like, Galileo, when, my countryman, when he was trying to convince people to look in his telescope and nobody wanted to look, right? Some of the priests, some of the clergy were refusing because they thought, oh, this is a devil's instrument, he wanted to convince them there were moons around Jupiter. Look at this, because it's now the Earth that is at the center of the universe, is the sun, and then there are other planets with little moons around, right? So the Earth is not unique. And so I was trying, I like this analogy that I'm doing. Basically, I'm trying to understand Bitcoin like if it was a science, because it has so many characteristics that makes it different from any other asset. It's not behaving like Nasdaq. It's not behaving like gold. It's behaving in a completely different way. They make it much more similar to natural laws than like an asset. And I know it sounds crazy, but I have actually a case. I have all the data to show that it's true. And usually, if you want me to continue to tell you the story, basically, the story is this, right? As a physicist, we are trained to plot data in a way where we are trying to find a relationship between two quantities, right? It could be pressure and volume. It could be how far an object moves versus time or stuff like that. Like if you're studying the planets, you want to study, okay, I have this planet, it's a certain distance from the sun, how long it takes the planet to move around the sun. And then maybe by doing that, you find a pattern, and then you're trying to understand why that pattern, what is the origin, what is the cause of that pattern. So I try to do the same thing with Bitcoin. In fact, even before I bought my first Bitcoin, I bought my first Bitcoin in 2012. 2012. I heard about Bitcoin in 2010, but I didn't act on it. I liked the idea, but it took me another couple of years. That is, you never want to wait with Bitcoin. It's a very bad idea, even at that time. But even before jumping in, being a scientist, I wanted to look at the data, right? So I downloaded the data. That is one of the beautiful things about Bitcoin. We have all this data, right? We call it on-chain data. We can download, it's open source, so you can try to get, the hash rate, the number of addresses, the number of transactions, the price, all this information. It's like the first experiment in human history where you can do this, because all the other set, maybe you can get the price, but you don't know how many users there are involved with that system. It's really this amazing experiment where we have money, where we have people, commitment. We have so many things coming together, and we can study all this, how these things relate to each other. So the usual chart that they show on TV is this chart, right? This is what we call linear chart. So basically, we have the price, like the normal price that people use, 10,000, 20,000, 30,000, and then sometimes there are dates on the x-axis, but one of the things I do, I use the number of days since Bitcoin was created. And right now, we are about 5,500, something like that. But every 365 will be a year, right? And so you can see it's about 15 years that we have of history. And the chart, it's not very impressive, right? Okay, sure, Bitcoin went from being basically flat in the beginning of its history. You cannot even see what was going on there. See, the first bubble looks like almost nothing. Then, the second bubble, then this huge big bubble where it went up to almost 65,000, and then it crashed, right? And this is what they show on TV, because most of the time they want to make fun of Bitcoin, like this very volatile asset, right? That, yeah, sure, maybe now it's worth it $70,000 or whatever, 63,000. But, look how it crashed in the past, right? It crashed so much that maybe lost 50% of its value or more. In fact, going from 60% to 60,000, let's say 65,000 to 16,000, it's big, right? It's a big loss. And so you're not really confident about this asset, right? If you're a normal investor, you think it's trash, right? Yeah, sure, it's going up, but who knows? It can go all the way to zero maybe one day, given the volatility, right? And so you are lost in the noise, right? This a physicist's way of thinking about this is that there is a lot of noise. Maybe there is a signal there, and is there a way of extracting the signal from the noise? That, by the way, part of my dissertation as an astrophysicist was to understand different methods of extracting the signal from the noise. That is really interesting, right? If you want to understand something like Bitcoin, because there is a lot of noise, but there is also a signal. And so one of the things that we do
for people that don't
yeah,
understand that, explain what noise is. What do you mean by noise? Give us an example.
So noise, and sometimes you can say that with almost anything. Some man's noise is some other's man signal, right? For example, when I was studying the brain has so much information that sometimes you have to exclude some type of data because otherwise you get overwhelmed. So it's basically, if let's say you're focused on something, right? Let's say, for example, I want to understand the trajectory of a rocket, and the rocket will blow, will move a little bit in the air because maybe there is wind or it's vibrating, etc. The real trajectory of a rocket is the signal, and the vibration and the all the additional stuff that is happening to the rocket, you can call it the noise. There are times where the noise is so big that you lose, let's say there was an hurricane and the rocket was moving around, it was kind of getting lost. Well, in that case, the noise is so big that overwhelms the signal, right? But in general, if a noise is small, we can focus on what counts or what matters to us. And it depends on your focus. Like if you are focused on the bubbles become your signal. If you're focused on the overall trajectory, that is your signal, right? In my case, eventually I want to understand the bubbles, but in the beginning, I wanted to understand if it was a general trend. So these bubbles are distractions, are noise. Does that answer your question?
Absolutely.
Okay. And so one way to eliminate or reduce the noise is to do this trick, because it's basically like a bunch of tools, right? In every profession, there are tools that we use. Like a carpenter, we use, something to get, a square angle or whatever. The same level, same thing with science. One of the tools that we use is we take the log of one of the axes. In this case, if let's say I take the log of the y-axis, and the log is this function in math where basically we imagine we are taking like a drone, right? So we are flying above the forest and we are trying to see the forest instead of the trees. And to do that, we basically look at big changes. So imagine I'm trying to describe how maybe different animal sizes relate to each other, right? Maybe their volume versus the weight or something like that. And I want to make a chart of all the animals, all the way from maybe a mosquito to an elephant. I will get lost, like the first chart that we saw, because the elephant's so big and comparing with the mosquito, that it will not be proportional. So one way of doing it proportional is to focus on big changes, like maybe by a factor of 10. So 10, 100, 1,000, 10,000. So the log allows us to do that, because basically imagine the log is this function where if I write a number in this thing called the scientific notation, sorry if there is so much technical stuff, but it's a relatively simple concept. So imagine I write 10 as 10 multiplied by 1, right? Then I write, in that case, I use what is called the exponent. So 10 to the 1 is 10. So if I have 100, it would be 10 times 10, that is 100, right? So that number can be written as 10 to the 2, right? Then I have 1,000, that is 10 times 10 times 10. That number will be 1,000, right? And it will be written as 10 to the 3. So you can see the pattern, right? 100 is 10 to the 2, 1,000 10 to the 3, 10,000 10 to the 4, 100,000 10 to the 5. So what the log does, you put this number inside this little box, and it spits out the exponent. So for example, in this chart, you can see 1, that is 10, right? This is when the price was 10. When it was 100, on the y-axis, we see 2. So that is the log of 100. The log of 1,000 is 3. The log of 10,000, 4. So it's not very difficult once you understand the concept. But the beauty of doing it in that way, now you see how different of a chart we have relatively to the first one. It's the same data, but now it looks much more organized, right? It looks like, see, first of all, the bubble in the beginning was almost invisible. Now it's very visible, right? This one around 2010, 11, right? When we had this big bubble, and then so these stars are the halvings. Then we had the second bubble, and every time they seem to go up basically almost by a factor of 10, right? So the first one was $10, the other one was around, a few hundred dollars, when the other one was thousands of dollars. The last ones was 60,000. But you see how we give the same weight in a sense, because we are all represented kind of equally. Of course, we are going up because we are bigger and bigger price, but it's much more uniform type of pattern. And even if you are not trained as a scientist, you're almost fascinated, right? This is the famous rainbow chart, right, that everybody's familiar with. It's like, it looks like there is something regular there, right? And you don't know quite what it is, because our human eyes is not very good in picking up this kind of not straight line trend. We like straight line. It's easy to say, oh, here there is a straight line, right? But if it is not straight line, it's more difficult. But it looks much more regular, and the bubbles seems much more contained in comparison with the general path, right? It seems that it's actually going up in a very consistent way. Now, it looks also is kind of flattening out, but that is actually an illusion, because the reason why it's flattening up is because in this particular graph, what will look a straight line will be an exponential growth. So if you have an exponential growth, is very common growth in science. Anytime you have something that doubles at a given rate, like let's say you have a interest, right, in a bank account, that of course is almost nothing. But imagine you made 5% every year, right? So 5% every year, you have this consistent gain. If it is compounding, it becomes an exponential, right? It's a very common type of growth that you see, like maybe virus. If you have a virus inside a vial or something, it will tend to double itself in a given amount of time. And so that growth is very fast, and it's called exponential. Well, in a graph like that, an exponential growth will look like a straight line. And you can see that Bitcoin is not a straight line in this graph. So it means that it's not an exponential. It's something else. And so we are trained as a physicist to, if we don't find a straight line immediately, right, in the linear graph first, because many relationships in science are linear initially. And then if you don't see a linear, you go to this other graph where you have a log of the y-axis versus the log of the x-axis. You don't see a straight line. You do another trick. That you use your ultimate weapon as a scientist. That is, you take the log of both sides. You take the log of x and the log of y. And this is very common in many areas of physics, but it's very uncommon with assets. In fact, this is why, I discovered this actually in 2018. I was already fooling around with these power laws, but I was looking at, like, for example, the relationship between price and addresses, where addresses can be used as a proxy for adoption, even if it is not exactly number of users. It's kind of proportional. You have to be a little bit careful. But I was finding power laws there. This kind of relationship that I will describe in a moment, they are called power laws. But then it took me time. In fact, I was the first one. I don't know why nobody else noticed, because it's very uncommon to take the logarithm of time in the context of assets. We do it all the time in other area of physics, but in assets, because almost never you get this kind of relationship, right? But you can see immediately what happens by doing this trick. So basically we have a price, the log of price in the y-axis, and we have a log of time in the x-axis. And what do you see? Well, I saw these guys, probably you know them. We have this show called What Bitcoin Did, and they show this chart, and they called it the chart that you cannot unsee, because it's so weird, right? Have you ever seen Bitcoin behaving like a straight line, right? Because yes, it has oscillations, right? It goes up and down, but now it's not curved anymore. It's like straight, right? It looks straight, and it's straight up, right? Yeah. It's so weird what is going on there.
That is really weird.
And so, as a scientist, though, I was trained to recognize this as a power law, because if you see a straight line, even a vaguely straight line, like this, right? Because really the price is oscillating around that orange line. So what you can do, you can use this mathematical tool, it's called a regression, that allows you to find kind of like an imaginary line that represents the average, right? That represents the average behavior of this sphinx that is kind of like straight, right? One of the things I could do to make it even straighter, I could average, right? So imagine I take the average of the price of Bitcoin over a month, over 5 months, over a year, and what you will see that these bubbles became smaller and smaller. Also, the bottoms became smaller and smaller, and they tend to approach that orange line. So the orange line represents the general trend, and in a straight line, it looks like a straight line. And the beauty of that is that I immediately recognize it as a power law, and I will tell you in a moment that this power law are more than just like a little model, right? It's not just like another guy that say, oh, okay, here I have this formula or this method, that algorithm that tells me what Bitcoin could be in the future, or how Bitcoin behaves. It tells us something very profound about the nature of Bitcoin, because this power law tends to be in nature for a reason. Usually there is some kind of mechanism that produces this power law, and many times these mechanisms are like iterations. Like imagine there is a process where the input is also the output, then the output becomes the input. So, and you go like in a feedback loop like that. And if you think about Bitcoin, you can imagine a lot of these type of feedback loops, right? For example, adoption, right? More Bitcoin there are, more Bitcoiners will be, because more of us are going to tell other people, we are going to orange people, more people. And so the input, that is how many Bitcoiners there are right now, is also going to influence the output. When you take the output, that is the new input, and you go in a cycle like that. And it turns out that you can show mathematically when you have a system like that behaves in this way, like in a feedback loop, you get these power laws. It's like a very relatively simple math exercise to show. And what is a power law? A power law is actually a very simple thing. I know that some listener think, oh, this guy is talking about these weird things. Actually, it's one of the simplest relationships. Right. Really, the simplest relationship is a straight line. If you have two quantities that are proportional to each other, let's say y equal x, it's one of the simplest things that you can imagine, right, in terms of a relationship between the two things. Well, the next step is, what if I take the power, right? So, for example, a parabola. So you have y equal x squared, right? Everybody studied a parabola. It looks like it goes up like this, right? Like a hockey stick. We say sometimes, oh, the price went parabolic, right? When we have an asset that grows very fast. Well, that 2 of x squared is what is called the power. So this is why it's called a power law. Every time you have a quantity that is, in fact, I wrote it here. See, I have this slide where if you have y equals some constant, the constant is what links one quantity to another. In this case, for Bitcoin, is price and time, right? And then really the most important number is this n. N is the exponent. And that number can be anything. It can be, like in the case of a parabola, it's 2, right? But it can be 3, it can be 3.5. It doesn't have to be an integer. It can be a negative number. In the case of a negative number, then what you will see is that it goes down instead of going up. It can be a fraction, it could be 1/2 or 0.5 or whatever. In the case of Bitcoin, that exponent is 5.83, but is very, very close to 6. And this number 10 to the 17, I know that can confuse some people, but it's basically, I have an app that I also can share with your audience that people can go. It's like a graphing calculator, and put it already this equation there, and you can click and you can play. I had many of my ex-followers playing with these, and they have a lot of fun, because you basically, this equation, it's the simplest possible equation. Can you imagine? And how do you derive this equation? This equation is nothing else than the slope, right? If you go back to this graph, once you draw that line using a computer algorithm that finds, the way you find that line is basically an algorithm that says, hey, let me find the line that has the shortest distance from every single point in my data set. And the algorithm finds this line. And then it gives you basically two numbers, because a line needs two numbers to be identified. It's the slope of that line and the y-intercept. So if we go back here, the slope becomes, and again, it's relatively simple math, but I'm not going through it.
Yeah, you're good.
But the slope becomes the exponent. And it's very important to understand this exponent, because I will show you some other example in a moment that of other power laws in nature, where it's almost like the DNA. So this number 5.83 is the DNA of Bitcoin. So it's so that important. This is one of the beautiful things about doing this methodology, because if you find a power law and then you extract this information that is the exponent, the power, then there is some meaning behind that value. And as a scientist, you're trained to try to find that meaning. What is the meaning? What is the consequence? What does it mean? Where does it come from, right? There is a mechanism, some kind of mechanism, some kind of cause that is producing that particular number, and that it becomes kind of the fingerprint of the DNA of Bitcoin. Now, this small number, all what it says, because you see, look at how this formula works. It's very simple formula. You give me a day from when Bitcoin was born, because all this is calculated from January 3, 2009. So let's say the day 0, right, when Bitcoin was created. Well, 0 to anything is 0. Right. I multiply by 10 to the minus 17. That is a very, very small number, like 0.1601. Yep. And the price is 0. That kind of makes sense, right? It tells you when Bitcoin was created, it was worth it 0, right? Mm-hmm. And then you tell me, okay, what about day 1, right? Day 1, this 5.3, we can round it up to 6, right? So to make it simple. So taking the power of 6, it simply means you multiply the number 6 times. So if we have 1, day 1, I multiply 1 by 1 by 1 by 1, it's 1, right? It's 1. Mm-hmm. So 1 multiplied by 1017. So that means at day 1, it was not quite 0, but it was 0.000161, right? It is 100 millions of a billion of a dollar. It was nothing, right? And now you can put 10 days, 100 days, and so on, right? And we have a video on my YouTube channel where my son is like a video maker, and we had a lot of fun, because we thought, what if we make this simpler for people to understand? And so we came up with this analogy of 1 kilo is equal to $1. And then what will be something in nature that represents the price of Bitcoin at different stages? So we show that within like a few hours, Bitcoin becomes the size, this mass of an atom. If 1 kilo is $1, then within few hours, Bitcoin had the weight of an atom. Within few days, I don't remember, but something like that, people can watch the video. Within few days, becomes the weight of a cell. Then within a month, it becomes the weight of a mosquito. It took about $800, 800 days, 880 days, something like that, for Bitcoin, according to this formula, to become $1, to be dollar parity. And so with this calculation, you can actually say, okay, when Bitcoin became $1, it took 800 days, so about something like 3 years, right? Two years, something like that. And if you go and check actually in a chart, when Bitcoin really became $1, it's something on the order like 920 days. So the formula is off by a month or something like that. That is extraordinary if you think, right? Because it's still an approximation. But if I can tell you the price of Bitcoin within few months, not just the current price, but also the price at any given moment of history of Bitcoin, when it was $1, when it was $10, people should go and check themselves. Try substitute days there and calculate what the price of Bitcoin is. It's amazing. This is why people are excited about this, because when many other people test.
You're saying I can just go and pick some random date right now on CoinMarketCap, and you can give me an estimate of what the price was?
Yeah, like for example, if you put
here, can I give you a date? Can I just randomly pick one so the audience can see?
Yeah.
All right. Hey, give me 1 second. You can keep talking. Give me a second. I'm going to pull up the chart, and I'll have you do it.
And I have actually a app. It's a free graphing calculator, and I put the equation, and then I will give you the link, and people can play with it.
All right, give me the price on. Give me the price on. Well, let me put the thing on the chart here so I can actually have it. That way it doesn't move.
I'm going to my, I don't know if you see these, but maybe no, but
No, I
I
can't see it.
can, yeah, give me the date.
Yeah,
And
go on October 17th of 2018.
okay, so to do that, actually need another app to tell me the days, right? Because we want to know many
Oh, yeah.
days. So give me the date. I have this app that tells me the date, the number of days. So
yeah, so
give me the date.
Yeah, give me the date is Wednesday, October 17th of 2018. So it'd be
Okay,
10/17/2018.
October 17. Okay. And I'm curious myself. Let's see if this works. Okay, so it's basically, so there are 3,574 days between, and you're saying 18 or 17? Which one? 2018, right?
2018, correct. Yep.
Okay, and Wednesday, 17 October, right?
Yep.
Okay, so I go to my app, I put this number of days, and the price that I get, it's 4,779. What was the price?
4,779.
Yeah, this is what I get.
So it was 6,862. But here's the kicker, right? Watch this. If I go forward 40 days, you're right on the freaking money, dude. Within 40 days, you were right on that price. Hold on, I lost your hearing for some reason. Hold on, I lost your is it on my side or your side? Hold on. No, it's probably on my side. Let me go back to the other screen where you're at. Okay, how about now?
Yeah.
Now I can hear you. Yep, that was my fault. My bad.
So yeah, if I put the date, this is what I get, right? And the idea is that
wow, that's
is a trend price, because the price will be below or above according, and is also, that is another thing that many people get confused, because sometimes they say, well, but the uncertainty is so big, it could be anywhere. Where we're in the cycle, are we close to a peak? Are we close to a bottom? Can you tell me by looking at the chart? Because I can look at it myself, but you tell me by looking at the chart, because that is also a beautiful thing, because you need you also put it together with the understanding of cycles, because it turns out, for example, that if we are close to the bottom, and this thing is almost magical in getting the bottoms, because when we are close to the bottom, we are usually like 50% below the trend. So you can give me any bottom you like, like a historical bottom, like for example.
Yep, here's one right here. It was 3,001, or you want the date?
Yeah, you can give me the date, and then usually is like about a 50% of a trend. This is where the bottoms turn out to be. And the top, they can be much higher because there is FOMO, and sometimes it can be like 5 times the general trend and so on. But you can always make a chart, and they will show you in a moment some of these charts where you can look at deviations, and you can say, okay, if we are above this deviation, let's say 50% from the trend, we are very, very close to a top. And I will show you in a moment why this is true. But it's a beautiful thing, because to be such a simple, silly formula and give us this precision in the price, it's almost magical. When people play with this thing, they get like, wow, how is this even possible? Like you did. And I wanted to show you this slide where these power laws come up everywhere in nature, and also in social phenomena, because that is the other thing I get a lot of pushback many times. You say, okay, fine, maybe planets, right? Because planets, for example, there was this scientist called Kepler. He found this Kepler law where you can look at the relationship between how far a planet is from the sun and how long it takes for this planet to go around the sun, right? The Earth takes 1 year, Jupiter takes about 12 years, and so on and so on. For the planets that are closer to the sun than the Earth, it takes less than a year. I don't remember Venus, I think it's 7 months, 8 months, something like that. Mercury, I think it's like a very short, like 3 months or something like that. But you see, they follow a beautiful, beautiful power law. So power law is anytime I take the log of one quantity versus the log of the other quantity, I get this nice, beautiful straight line. I know it's a power law. And then remember, by measuring the slope, I can tell that magical number that is the power, that is almost like a fingerprint or whatever phenomenon I'm studying. And this is our beautiful Bitcoin with this power law with 5.8 being is fingerprint. But one of my favorite is this one. This is called the Kleber's law. So what are you seeing here is the relationship between the mass of an animal. So you give me an animal, but these are mostly mammals, but you can see here there are even birds and other kind of animals. You give me the weight of an animal, and then I'm going to look at the energy of the animal. And the energy, how much energy the animal needs, how much energy per second the animal needs to survive, right? The metabolic rate, what is called and is measured in watts. And notice, for example, human beings, if you ever wonder how much energy we need to survive, is the same energy of a bulb, 100 watts. This is all what we need, 100 watts of energy per second, 100 watts to survive. It's a really interesting to see here in this graph, right? Women need a little bit less, and this, whatever that means, right? Because men probably need more energy, we are more active, whatever, and science is not, it doesn't care about these things. It tells us the truth about these kind of things. But the beauty is that you can see again, if I do a log plot of something like this, it's a very, very precise straight line, right? Now notice, when you're dealing with things like biology versus planets, you start to see, like when we're talking about noise, start to see a little bit more noise. Noise means here that instead of falling perfectly, every dot falling on this line, there is a little bit of randomness, right? You could call it noise, probably because every animal is slightly different from another animal. Maybe emphasize, being an herbivore versus a carnivore. Maybe, there are birds, like notice how big the deviation from birds is, right? Given their weight, they use much more energy than what you will expect if it was a mammal, right? Because they are flying, they use more energy, but it takes energy to fly. And so it tells us a lot of things. By studying, you could spend months or years, right? In fact, there are some scientists that make almost a career in studying stuff like this. And again, by looking at the slope, in this case, the slope is 3/4, and it tells us a very beautiful story. Basically, the story is this: if the energy of an animal will be twice, if I make the animal 2 times bigger, many animals, like the elephants, will not exist. Why? Because by the time I go from the mouse to the elephant, right? The mouse, it's about like a fraction of a kilogram, right? The elephant is almost 10,000 kilograms. Well, we are talking about almost 100,000 times bigger animal than a mouse, right? So that will mean 100,000 times more energy. An elephant will eat everything around itself if it needed all that energy. We are already eating almost all the time, like many herbivores, right? It will not have enough energy to survive. So we will not have this beautiful animal, elephants, right? This so cool animal with this big trunk and big ears, etc. It will be a pity, right? But they do exist because of that 3/4. So by the time let's say you go 100 times up, then you take the 3/4 of that 100,000, and instead of getting 100,000, you get 10,000. You get a discount in energy because the number is smaller than 1 of almost 10. So the elephant needs to eat 10 times less energy than if energy went proportional, like linearly proportional, to the weight. So nature somehow found a way of organizing itself where it saves energy as you become bigger and bigger and bigger. It's a kind of economy of scale, if you wish. So you see how beautiful things we can learn from these power laws. We can learn a lot about the phenomena that is going on. Then, some scientists go deeper and say, why 3/4? No, why not 2/3? Why not 1/2? Why is 3/4? What does it mean? And then it turns out it has to do with the vessels inside the body, how the energy is transmitted. Because basically, it turns out that one of the ways that you can think about a lot of these systems, it's this word that is network. So if you have a network, that means you have a lot of components, and these components talk, interact with each other, they communicate, they have energy transfer, matter transfer, like cells, for example, in a body, right? In an organism, the cell communicate with each other. They transfer. I make this protein, you make this other, we exchange. It's all automated, but there is a lot of interactions between these components, right? We call it, in science, we call it a network. And scientists develop an entire theory, like there are big books that say, okay, this is a property that you will expect by a network. And the beautiful thing that it doesn't matter if you're dealing with an organism, if you're dealing with a city, because a city is also a network, right? There are different components, different parts of the city, different people that interact with each other, maybe different departments, etc. It can be a city, it can be a language, because also languages, when you build a language, verbs interact with nouns and all kind of stuff like that. You tend to have these power laws. They come up like naturally from this type of interactions in networks. So if you have networks, you have this tendency of creating power laws. And that is one of the reasons why, or the main reason why we have these power laws in Bitcoin, because it is a network. And in the beginning, it was just an hypothesis. And then in the last few months, I made a bunch of discoveries where I can show it that actually is a network, and it shows network properties. But before we go there, first of all, I want to see if you have any particular question, because this is just a monologue. Otherwise, you want to ask me a question? Do you have anything that you want me to clarify?
I'm just taking it in. I'm enjoying it. So it's so interesting to me. I have so many
Perfect.
questions, but I want you to keep going. So you're on a
Yeah.
roll.
So, and in cities, for example, so there is these are what happened with the physics. He started to study things like planets and stones falling down, because of gravity or whatever. And then we started to study organisms. This is something that happened relatively recently. This scientist is named Jeffrey West. He's a very popular. He does also education. He wants to tell people about this beautiful science of the power laws. Another word for power laws is scaling phenomena, because we're talking about this scale, right? Going up by a factor of 10, 100,000. It's also called scaling laws. And so he has a beautiful book that I suggest everybody that is interested in understanding Bitcoin to buy this book and read it, even the audiobook. It's called Scale. And I will show you the title in a moment. But one of the things that he did, right, he started to work in biology, and I heard some of the videos where he says, I got a lot of resistance from the biology people. They didn't want to listen to us. They didn't want us to use physics methods in biology, because it's like this newcomer that comes and brings in this new perspective, right? Same thing happened to me when I started to study the brain using physics, and I got some resistance from neuroscience. But, I did also a lot of progress, because it allows you to see things that people didn't see before. Same thing when I started to use a physics method to understand Bitcoin. I discovered things that nobody else saw before. And people study Bitcoin on-chain data for years, before I discovered these things. So it sounded weird to me that that was the first one. But, maybe because I looked at it from using physics eyes. So one of the things that happened even more recently is actually using this method of physics to study human phenomena. You can study economies, you can study cities. Cities are almost perfect because they're really network. And I love this because, how Saylor, for example, he says that Bitcoin is this city in the digital world, this digital city and we are moving into it, right? This shining city in the digital world. So I don't remember the exact words, but he says something like that. Well, cities behave exactly like power laws. Like you can look at the GDP of city as a function of the size of a city, and it's a beautiful power law. You can look at the number of gas stations. So you will think, there are sometimes people say human beings are not ruled by mathematics. No, they are ruled when they actually are working as groups. They became like little particles in a sense. I know it sounds weird, but it is true. And so the number of gas stations in a city, it's a power law. So there is a little simple function that says number of gas stations in a city equal, size of a city to some number, like the power. And you can calculate how many gas stations you're going to expect in a city, exactly like we did with Bitcoin, or the number of terrorist attacks. Can you imagine something weird like terrorist attack that you think is completely random? No, it has to do with how big a city is. Bigger the city, more likely is that there is a terrorist attack, and it follows this power law. So many phenomena where we see power laws everywhere. And so, there is this book that I was telling you, Scale, and look at what it's called. It's called the Universal. Universal means it doesn't matter if it happens in a city, it doesn't matter if it happens in an organism, in planet. It's similar, right? Of course, how a city works will be different in details, and as a scientist, maybe we want to dive in and say, okay, our city is different from an organism. Well, there will be some different, but also how similar it is, right? So this when we use this word universal, and laws, because laws in physics or in science, it means a pattern, right? It's different from the law of gravity, right? It's a very strong pattern, but even gravity is a pattern, right? We don't know if it continue to work tomorrow, maybe not, It's just that we saw that we do these experiments where you drop a stone, it falls, we never see it floating in the air unless there is an hurricane, right? In that case, then everything flies, even houses or whatever. But in general, gravity makes things fall. So this is why we call it a law. But law can mean also a very regular pattern, right?
Hold on. The law of gravity, I thought it was the theory of relativity.
Well, yeah.
Because there's no math that could prove gravity.
Well, yeah, right. In science, we never prove anything. But, we do say the law of gravity, right? The law of gravity is one object multiply the other object, divide the distance square of the object, like Newtonian theory, right? The Newtonian theory of gravity. But most of the time we use it because it's an approximation, but it's pretty good approximation, unless, you're close to a black hole or you're traveling very fast, close to the speed of light. We still use this law of gravity that Newton gave us, right? So we call it the law of gravity. But I'm trying to say there are some laws that are stronger because they have to do with physics, like objects and material stuff. And then there are, kind of, you can put quote unquote laws of a city, right? You can say the law of a city, like New York is this, where I'm expecting as New York grows to have this number of gas stations, number of libraries, GDP, right? It's still a law, but there is much more noise, right? So you see, when we went to organism, we had more noise. When you go to people, you get even more noise. But it's still a very regular pattern, right? And so this is why I really suggest people to get a copy of this book. It's very beautiful done. Plus, this Jeffrey West has also like TED Talks and other nice talks that he gave. He's very entertaining. He's an English scientist and very, very eloquent. And it's almost like poetry in a point, because the other thing I wanted to tell everybody that if really turns out Bitcoin is a power law, it has a lot of beautiful, almost philosophical consequences, because power laws have to do with, like we saw with the animals, economy of scale. They have to do with the path of least resistance. They have to do with some kind of intelligent principle, right? It's not like, there is some little being inside an elephant that say, hey, let's organize ourselves like that. It's just how nature works, right? All the different interactions, all the different laws of nature that make the organism try to be optimizing, right? To optimize whatever process is doing. So the fact that Bitcoin behaves like a power law what means that somehow this beautiful intelligent system that is this thing that we are in love with behaves in this very organized fashion. In this trying to save, it's trying to optimize itself. So it's a beautiful, beautiful idea. It tells a lot of the things that we associate with Bitcoin, from an intuitive point of view, like, it's this, it's better than any other asset, that is, it knows, in a certain sense, Bitcoin knows better, because it knows how to grow and what to do, etc. All these things is a city are actually proven if the theory is correct. We have now the physical and mathematical evidence of it, because it's actually, we can tell. And so I'm trying to actually write a scientific article that I want to publish, in a journal, because a lot of my discoveries, I do it in social media. Even when I started this thing, is instead of publishing in a paper, the problem with the paper is when the people don't read it. And my goal was to share this with other Bitcoiners. This is why I did it in social media.
Yep.
But you can do both, right? Because it's also important to have other scientists evaluating this theory and say, okay, Giovanni, you're right, or maybe you did stupid things. Some of the people that follow me on Twitter, or I am connected with them in Twitter, I don't know if you know this guy. His name is Fred Krueger. He's a Stanford mathematician. He's a very, very clever guy. He studied math in Stanford, and then he went to work for Wall Street, and he made a ton of money doing that. So it's not just some theoretical math. It's also one of these quants that actually was very successful, right? Some of the most successful fund, like there is this medallion fund by Simmons. He's a billionaire, right? It's there was a point where this fund was making like 60% a year, and he's all mathematician physicist. That he has interviews where he says, I don't hire economic people, just hires. You have a PhD in astrophysics, hard. You have a PhD in economics, I don't want to talk with you. And because it is what he says, and it's the most successful fund in history ever. And Brilliant. Fred is one of these crazy guys, one of these quant guys. They are called like this in Wall Street, and he looked at my power law, because I was trying to get attention from him. I was posting in his account and say, hey, look at me, look at my power law. And he didn't notice for some time, and finally did. And he said something like, oh, there is no doubt that Bitcoin is an unstoppable power law train. This is what he would say. And another expression that he says is, look, for this thing to be due to chance is the same thing. Of course, he didn't calculate it, but it's a hyperbole. He says, imagine to go on top of the Empire State Building and you are dropping a coin and you're trying to get it inside Dixie cup. This is how he calls it, this little Dixie cup at the bottom of the Empire State Building, and you drop it exactly there. That is how likely is that this thing is due by chance. Because any person that has a little bit of math understanding, he sees that beautiful straight line here, and he says, that is not due by chance. And so since I discovered this thing in 2018, first of all, remember, it's 2018. So that means I am doing this thing for 5 years. So I can show you my prediction 5 years ago versus today, and you can see that Bitcoin did exactly what I said it did. So this is called, in this field, is called out of sample, right? Because one thing is using already done data, and another thing is say, okay, let's see how it works in the future, right? And I have out of sample of 5 years. But it's unthinkable. I don't think there is anybody in history that ever predicted anything in the financial world 5 years ahead, and tells you, okay, it's oscillating, but the general trajectory, the general trend is what I predicted 5 years ago. And not just that, another person in the circle of Fred is this guy. His name is Sins. He's a finance professor, and he actually DM me one time. He said, hey, I understand where you come from because I work with physicists, and actually I learned a lot of things from them. And he did an analysis where he took half of the data and then he projected in the future, and then he took the entire data and he saw how the straight line looks like and compare the two, right? It's one of the tests that you can do. How stable is this prediction? And this word, he was interviewed by Fred, there is a video, so I'm not making this up, but this word, this finance professor that does this as a job, to analyze data from companies, from stocks, all kind of things. He said, in all my careers as a data analyst of financial data, I never saw anything like this. He literally says that. And again, it's not me, it's Bitcoin. What I'm trying to say, how beautiful, how amazing Bitcoin is. And the new thing I discovered, this is why it's a theory now, it's not anymore a model, and the difference between a model and a theory is a model. It's like when you see a little pattern and you say, maybe there is some regularity here, maybe this regularity will continue to go, but you don't know what causes the regularity. You don't know what is behind the regularity. And so for a long time, I was beating my head. You remember where I told you that 5.8 is almost like the fingerprint of Bitcoin, right? And I knew that had to be important because this is how these power laws work. If you understand what that number what the number is caused by, or what are the causes, remember, like in the Kleber's law, right, the 3/4 is due to all the interactions inside the body, all the cells, and so on. This is what scientists found out eventually. If I understand where the 6 come from, then maybe I can understand what drives Bitcoin, why Bitcoins behave like the way it does. And I spent a lot of time. I was walking, I was taking showers, I was doing all kind of things. And at a certain point, I decided, you had a breakthrough when you drew the price as a function of time, like a log of time. Why don't you take everything you know about the blockchain and you do power laws of everything? But the power law of price versus addresses, the power law of addresses in time, the power law of hash rate in time, the power law of price and hash rate. All these graphs of log of one quantity versus the log of the other. And look at this. This is what I found. This graph, this chart shows all of them are power laws. It's crazy. Again, I didn't never see anything like that, where a system shows power law in all its important elements, because the number of addresses is basically adoption. It's kind of proportional. We can use it as a proxy of adoption. You can use the hash rate as a proxy for the energy that the system is using, because of mining. And then all these things happen in time, so we can look at how addresses change over time. We can look at how hash rate changes over time, and there are all power laws of time and power laws of themselves. So there is a very precise relationship between, for example, the number of addresses and the price. You tell me the number of addresses, I can tell you the price, and it goes with the square. And by the way, this is a very famous relationship. There was this engineer, his name is Metcalfe, and in the 80s, he's the inventor of the Ethernet cable and other invention. He's a very famous guy. He got all kinds of prizes and so on. But he created this thing that is called the Metcalfe law. So he was interested in giving a number that represented the value of a network. And in that case, the value means how useful it is. So imagine you have a bunch of telephones and they are connected with each other, right? And you want to see, well, what happens if I double the number of phones? Will the utility of these networks go up with 2 or something else? What he found out, it goes up with the square. So, for example, if you double the number of telephones in a network, right, the value, the utility of a network goes up with 4. If you triple, it goes up with 9, and so on and so on. You quadruple, it goes up with 16, with the square of it number that and it's called the nodes, the number of nodes in the network, how many elements the network has. So, and because it turns out that has to do with the number of connections. So if you have a 100 phone, the number of connection will be the square, that is 10,000, and so the value now it's 10,000, not 100. So it depends on the number of connections, the value. Well, that is what happens with Bitcoin, because if you look at this graph where I have price, it's a little small, but I can tell you this graph here that says price as power of addresses. The price is on the x-axis, is a log, the log of price, the log of addresses. We use addresses here as a kind of a proxy because we don't know exactly how many users there are, but it's going to be proportional to the number of addresses, because it's a rough proportion, but you can see it's a beautiful power law, and it's not exactly 2. I'm rounding it up, like it's not exactly 6 for the power law in time is 5.8, but I'm rounding all this number to the closest number to make it simple. So it's close to 2. It's a number close to 2, but is exactly what Metcalfe predicted in his theoretical calculation. So this is actually a validation of this theoretical result that this guy did in the 80. Now we have an example that actually it works, from the mathematics, from the data. And so it's beautiful. And then you say, okay, what about the adoption? How does it grow in time? And many times people use this, what is called the S curve. So they claim, without any evidence, because they don't show the data, I never saw anybody showing the data, that the number of users, so in this case Bitcoiners, grows up like a S curve. Well, it's a good hypothesis because a lot of technologies have that kind of shape, right? You maybe saw this shape. You can find it online. if you say, it's called the adoption curve, right? It basically shows that initially the adoption is very slow because very few people adopt it, right? Make kind of sense. And then all of a sudden, a lot of people join in, and it goes very fast. It goes exponential. And then when everybody starts to adopt it, it kind of flatten out, right? Because you get to that kind of almost like a saturation point. So it's called the S curve because it looks like an S curve. Well, Bitcoin doesn't follow an S curve. It follows a power law where the adoption goes with the power of a cube. So you double the number of time, right? So for example, in the next 15 years, we double the time that Bitcoin existed. We are going to have 8 times more Bitcoiners because it's 2 to the cube is 8. And so we can calculate how many people we are going to have, how many Bitcoiners we are going to have in 15 years from now. It's going to be 8 times more if this thing continues to behave in this way. Now, I wonder about this thing. I say, why a power law? I was expecting an S curve. And in fact, for a long time, I was fooling around with models like that, where I was using some kind of an S curve. And when I decided to do this thing of, okay, let me just see what the data says instead of making up stuff, right? And when I found this beautiful power law, look how straight it is. It's amazing, right? How beautiful straight line you have. And it turns out that a lot of virus-like phenomena, and there were an example like AIDS, for example. I know that it's a bad analogy, but instead of being a bad virus, this is a good virus, right? As a virus of the mind, right? We are infecting other people with this idea of Bitcoin. It turns out that a lot of virus-like spread, in particular in networks, it becomes a power law instead of being an S curve or an exponential growth. And in particular, that happens in 2 conditions. One, if you have like a super spreader like you, right, that are impacting a lot of people, you're orange peeling a lot of people versus like the average guy that maybe orange peel his own friend or whatever. So if you have a situation like that where we have like super nodes, or if you have like something that kind of slows down a little bit the growth, like for example, in the case of AIDS, people know that you can get AIDS by having sex, so maybe they're a little bit more cautious. They take precautions like different type of protections during sex. So that slows down the spread, and so it becomes a power law. And guess what? AIDS in fact spread with the power of cube in time, exactly like Bitcoin. And and I found like dozens and dozens of papers explaining this thing, like how you get a power law when you have this kind of virus where if there is some decision making involved, and in this case, it takes time. And in fact, it's a good thing that people think about Bitcoin, they want to learn about Bitcoin. They don't jump in, right? It's not like a meme coin. You need to be aware of what you're doing. And that slow down the process. It's still very fast because the cube of time is still a big power, right? It goes very fast, but it's slower than an exponential growth. And so look at this. Basically, we have a formula when you combine these 2 things. And then, I found out, before I tell you the formula, I found out also the hash rate is connected with a power law. In this case, it turns out that price equal hash rate to the 1/2. And then, also we can see that the hash rate is a power of 12. So hash rate 12 is crazy. It's like hash rate is growing very, 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 very fast, right? So all of them are power laws. And so I put it here. I think this comes from the Bitcoin standard, right? It's this diagram where basically you have like a loop. So, everything here is connected to one of these power laws. Like, for example, you can think, okay, this when Satoshi started the network, he didn't have a lot of people in the network, but he had some friends that like the idea. And so, the demand of a store of value or whatever it was, this network started to grow up. That makes the price. In the beginning, there was no price. It was mostly like a curiosity, or maybe, I want to try this thing, but eventually it became the price. So the price increases as there is more adoption. And you see how there is a power law for each step of this circle. And then I didn't invent it. I just show that actually there is real math behind this beautiful feedback loop. And then the price goes up, more miners want to come in, and so this how the hash rate goes up, right? And it is related to price. See, there is a very precise relationship between price and hash rate. So bigger the price, more hash rates. And then there is investment in the mining operations, and this is why there is this continuous growth of the hash rate. There is more and more investment, and that improves the security of the network because it's more difficult to do a 51% attack. There is more decentralization and so on. And so this kind of closes the loop here. And so it's a beautiful, beautiful thing where this is why it's a theory, because every single aspect of Bitcoin growth and behavior is explained by this theory. And in fact, there is even, I call it a corollary, like an explanation of why bubbles happen. But if we have time, I can tell you. But it's kind of a side note, because the real behavior is this general trend, and then there are the bubbles that are on top of the general trend.
Can I ask a question there? What is the, can you go back to the previous chart, the one that you just had up there? On the Bitcoin price power law in time, what is the farthest deviation? Like, so if your center line is here percentage wise, how far does the price fluctuate above that? And what is your, so if your chart saying like, okay, by January 1st, 2026, Bitcoin's going to be 150,000. What is the wiggle room there as far as percentage wise? How far has it been off in the past?
And you can see how the bubbles are becoming smaller. Right? So this deviation actually became smaller as the time passed by. And by the way, the first bubble here is kind of like an anomaly because it doesn't really get us. It's not associated with any halving. It happened before the halving. It doesn't have a regularity in time like the other bubbles. So I usually exclude it. Eventually, I want to go back just for completeness and trying to understand where that bubble come from, but I usually eliminate it because I'm trying to understand.
That was probably the Silk Road.
Yeah, exactly. Silk Road, or maybe Mt. Gox, some crazy stuff, right? That was not associated with the halving. While the other bubbles are really very precisely associated. And I will surprise your audience saying that differently from Plan B with this S2F model, they have nothing to do with supply or lack of supply or reduction in flow. Nothing. In fact, I can demonstrate that is the case. It's FOMO. It's mostly FOMO. People knowing about this event, that is the halving. It's very important for the miners because it's basically like an upgrade for the miners, a way of keeping up with Moore's law. And I have like an entire explanation in my article. I wrote this very long article, and I have an entire section about why bubble exists. And in fact, my son, that is a video maker, he also made a video about this, and the listeners can go and watch this video. We have a series, we call it The Physics of Bitcoin. We have this 10 minutes, very high production video where you can watch them in a sequence, and they introduce you with power law, they tell you about this diagram. Then we have one about the bubbles, and then we have one about this thing that I will tell you in a moment that is called scale invariance. It is really the most powerful prediction about Bitcoin being a power law, why we can use this idea of scale invariance to actually make prediction in the future. But to answer your question, so you can do it in different way. One way is calculate the typical deviations that you get around this general trend. And so it's called the standard deviation. So it's an average deviation. So it turns out that the bubbles are about 2 standard deviations. They are, you notice that it's not symmetric, right? The bubbles are much bigger than the bottoms, and the bottoms are about 1 standard deviation from the trend. So it's relatively small deviation if you look them in these log charts. And the beauty of it also is that they are not random in the sense that that is sometimes I hear this criticism of this model and say, well, if there is so much deviation, it can be anywhere. No, it cannot be, because we follow a very precise pattern. There is a very precise way of knowing where we are in the cycle. Like we spend about 2 years in the bottom along the power law. We'll show you in a moment. You see how it seems like to follow this very, very precise pattern at the bottom that kind of parallel to the trend. And it's a bottom that we almost never go down. It's one of the strongest prediction of this model. And then we have a top that happen at very precise time. It takes about 1 year to go up and it takes 1 year to go down. So if you actually use your knowledge of the cycles and the trend, then you can tell almost like with an uncanny precision where we are relatively to the trend. And so you can actually use it if you want to do DCA, or maybe you want to take some gains and then rebuy at the bottom. Depends on your style. Because see, that is the other things that we are trying to say, that it's not just science, it's also technology. Because science is beautiful and you can learn a lot of things, but it's even more beautiful when you can actually apply the science, so you can make airplane fly, and do all kind of interesting things with science. So it's also technology. And this, we have indicators that develop these trading view indicators based on the power law, and people are playing with it all the time, and they almost have like 100% success rate. And I know it sounds crazy, but again, it's how beautiful, precise Bitcoin is, And so remember, I was telling you.
You never told me, what is the percentage? What is the farthest it'll go off?
Right. So it's 2 standard deviations, for the tops, and 1 standard deviation for the
But
bottom.
what does that mean as far as like percentage wise? What is that from?
So for the
price
first
at
bubble,
100,000, how high could it go?
Because so for example, the first bubbles, because there was so much variability, to standard deviation was huge. So that was basically almost like 10, a factor of 10, from the bottom, but from the trend, it was more like 3, like maybe a factor of 3 from the bottom, right?
So
from
300%?
300% from the trend, right?
Okay.
And now, because we are becoming smaller, I also have a model for that of how big this decay of the tops is. I have actually a mathematical model for that. I can tell you what will be the next top. So the next top, for example, is going to be 250,000. Is what we calculated. But I will show you in a moment. So here is one of the punchline, one of the strongest punchline. So do you remember I was telling you how important that 6 is, right?
Yep.
That is like the fingerprint. And now we know where that 6 come from. That was, something that I was breaking my head against for a long time. And then one night I was thinking. I did this graph and I started to see the pattern, and I was like shocked. It was like, oh wow, I cracked Bitcoin basically. So it turns out, right, remember when I told you that Bitcoiners, right, the adoption goes with the cube of time. That is like similar to some of the virus, like AIDS, for example. So when you have in this case, it's like I did something that I should not have done. Okay, so basically, it's like a virus that is spreading like these ideas about Bitcoin that is spreading like a virus. And then there is this Metcalfe law that says that the price is proportional to the square of the Bitcoiners. So when you combine these two things, you have the price equal to the Bitcoin square, but because this grows with the time cube, you take the square of a cube, you get 6. And this is why the price goes with 6. And you see, it has all to do with network properties. So we go beyond being a model, because now we have causative links, right? This is when you really start to do real science. If I'm telling you this is not due to some kind of random process, but there are very precise mechanisms that describe how Bitcoin behaves, we are in a completely different realm. We are telling you, okay, Bitcoin is more like a natural process than an asset, and it's predictable. And one of the reasons, and by the way, it's so cool. One question that you could have is, well, which kind of addresses you use? I use every address that is not a noise, in the sense that I took all the non-zero balance addresses. So basically everybody. But then you can ask the question, what if I take addresses with 0.5 Bitcoin? What if I take addresses with 1 Bitcoin? So basically bigger and bigger, right? What you will call dolphins and whales and so on. What is going on with them? Well, it's an amazing kind of thing. What happens is that bigger is the amount in that address, bigger the impact, where instead of being square, maybe it's 5. Then if you go to dolphin, instead of being square, it's cube. So it starts to go from very huge numbers all the way to relatively small number, all the way to 2, that is kind of a limiting low number. So everybody. And then you look at how fast is the growth of these addresses. And bigger they are, slower they are growing. That kind of makes sense, right?
Mm-hmm.
But look what happened. When you multiply these two numbers, remember how we got that 6. You take big impact, slow growth, equal 6. Middle impact, middle growth, 6. Small impact, very fast growth, 6. So everybody, no matter how big they are, the small fishes, big fishes, they all impact Bitcoin in the same way. It's not amazing. And again, you can see that it's not something that you will ever get by chance, right?
No.
There's something crazy going on with Bitcoin, where it behaves in this very organized fashion, where everybody's contribution is the same in the end, in terms of how the price grows.
Mm-hmm.
And the network somehow knows, it knows because the interactions, how people buy Bitcoin or sell Bitcoin, it's not like a normal asset. It's not like what happens in the market. It's all, basically random, and you cannot have an equation to describe, right? But with Bitcoin, you can. It's so crazy. I know it sounds crazy, but if you look at the equations and the numbers, it's exactly like that. And so, and this is why I'm saying all these analogies that we have at Bitcoin is like a city. And then I did this analogy of a Ouroboros, it's like an ancient symbol of a dragon that eats his own tail, because, it's basically this loop that goes on and on and on. These are these beautiful iterations that we see, because when you have something like that, it's very robust. It's very difficult to shake it, right? It's very difficult to make it crash. Like, for example, you see this graph here. This graph is where I emphasize that bottom line, right? The bottom line, instead of drawing the line through the middle, I'm eliminating the bubbles, because I'm considering them like a deviation. So like noise in a sense, right? And say, well, maybe the signal is really the bottom, right? And look how amazingly the bottom lines up. You will never have expected unless you have this chart, right? This chart really highlights that something is going on there. And what is going on there, it turns out that is basically the miner's capitulation line. So if you go below that, the miners start to lose money. So their operation is not anymore, doesn't make money for them. And so the system protects itself from that. Somehow it knows, and it doesn't allow the price to go much more below from that. It's almost like, and this also can be used to identify very precisely the bottom. I did call the bottoms many times, like in the past. I say in 2018, I say when we were here, I say, guys, we are reaching the bottom. When we were there at 16,000, I say we are reaching the bottom. And look also here at, again, these are days from Genesis block. Look at 4,250. You see that little dip there? No, it's not little. It's actually pretty big. Do you know what that is? Do you have any clue of what?
That was the liquidity crisis in 2020.
Associated with what?
Associated with the COVID-19 pandemic.
Correct. That is the COVID. That is COVID.
Yep.
And remember what happened to certain assets like oil. They went all the way to minus the numbers, right? It's basically they were paying you to bring oil at home. Get a barrel of oil and we give you money if you do that, right? And with the COVID, with Bitcoin instead, what happened? It arrived to that red line, it flashes below that, and it bounced back. This is how wonderful this discovery of the power law is, because actually tell us that it's self-protecting. There are all these mechanisms, because that is the other thing that happens with power law, is associated with the homeostasis. Like organisms have homeostasis that basically the organism tries to stay in the middle, right? Because this is where it is good. If you run too fast, your heart goes up because it has to do a task, but then it wants to go back to its normal rate, right? If you don't go to that normal rate, something is wrong with you. That is all ruled by power laws, all these mechanisms of regulation, homeostasis, and so on. Bitcoin has some kind of homeostasis going on with it. And it's probably driven by the difficulty adjustment, right? Because it's almost like some kind of regulation mechanism, like almost like a thermostat, right? With difficulty adjustment works like a thermostat. All these things that make Bitcoin a mix between human intelligence, machine intelligence, human energy, physical energy. All these interaction create this beautiful, very regular system. And also the cycles, like I was telling you, this blue dot, we spend about 2 years in these blue dots. And that is the other, these memes that has 3 green bars and then 1 red bar, right? It's actually true, because if you think, if every bar is a year, we spend 1 year along the red line, and we are going up because of the power law. We're going up with this power of 6, with that little formula that I told you. And then we spend another year there, again with this power law of 6, and then we leave a power law. So it's a deviation, and we go even higher, right? So we go up, more up, and then we go home, right? We go back, and you see how it's crazy how it goes back to that straight line.
Yep.
I mean, do you think that something like this can be due by chance, or it's something random? How can it be? It cannot, right? It's something very regular, and something wonderful about Bitcoin.
So what would break, like, let's say you pick a date in 2026, or when are you saying the top is, the 250,000 ballpark range?
Go with the cycle, right? And I have also other tools like these. I show you what they did.
I'm curious on what would cause you to admit that your thesis is wrong. What price point would you have to hit? By what date would you have to say for that to be not just another anomaly?
This is why I want other scientists to look at this thing, and some of them already did, and they all agree that it's true, right?
Yep.
Now the question is, at this point, at least, is history. So we need to, at a minimum, people need to recognize that Bitcoin did this for 15 years, because I don't think it's due by chance. I don't think it's mirage. I don't think I did some mistake mathematically. It's true. Bitcoin has behaved in this crazy way for 15 years. Could it be that is going to do something else in the future? And this is where this idea of scale invariance come from. And what scale invariant means? Scale invariance is another, it's like, I don't know, it's like saying that dollars come with 2 faces, coins come with 2 faces. It's almost like you cannot have a coin unless you have 2 faces, right? Well, okay, unless it's Bitcoin, and then you don't have any faces at all. But this is why it's Bitcoin and not a normal coin, right? I'm trying to say there is a very strong property, like it's almost like another way of describing power law, that is the scale invariant. What does it mean? It means that you can also use this expression, everything proportional. Do you know when you have a triangle and you make it bigger, right? It's something that we learn in school. Everything grows in proportion, right? Every side of a triangle, as I make the triangle bigger, is proportional, right? The bottom side, the vertical side, the hypotenuse, everything will go proportional. Now, you can use the same idea and look out when you have a power law. By the way, you see this red line?
Mm-hmm.
So this is where blue line is where our prediction in 2018 was. And the red line is basically up to, it's not even like most recent data, because it continues to go even more like along the power law. But here it's an update to January 16. And the red line is this. Do you see how it really went through this oscillation along this line that we predicted? This is how accurate it is. We predicted 5 years ahead that it will continue to do this progression. So you could have used this idea of scale invariance, where you can say, hey, let me draw a triangle up to wherever we are. Imagine that we are in 2018, basically the blue dots, right? And then let's say I wanted to make a projection, and I stand the triangle, I make it bigger, so I make it all proportional up to some future date, right? That is whatever, 24. Well, all what you have to do is to extend the triangle, keep everything proportional. So you're keeping the change in scale, because it's all, this is why it's called scale invariant. Invariant means not changing, non-variant. And scale means these changes in 10, 100, and so on. So if you change the scale in proportion with hundreds and thousands, and you do the same thing in time, so when, instead of having 100 days, now you have 1,000 days. Instead of having 1,000 days, you have 10,000 days. So if you do the proportion, in the same in the scale of price, in the same scale of time, you get this behavior that is called scale invariant. And the reason why it will not change without one of the strongest prediction, because when you do a theory, theories have always predictions, because otherwise we are not theory. They need to predict something. The prediction is that Bitcoin will continue to be a scale invariant system, because this is what scale invariant systems do. This is why they are called scale invariant. Look at this, what happened. It continued to do the same thing when it was few cents, when it was $1, when it was $10, when it was $10,000, $1,000. So this scale invariant behavior is what characterizes the system. It's almost like, it's part of his identity. And so if we want to go another order of magnitude, so how big was these changes of order of magnitude? Remember, I told you we made this video so people can watch this video, but another example, I have it here. So I did it with the animals, right? So if you look at the different sizes, different scale of Bitcoin is like, if you go all the way to 2010, and if you went all the way to the first USD transactions, there was like one of the first transactions with USD was $1 for 10,000 Bitcoin. Can you imagine how incredible of a deal was? If you go all the way to that, you will actually have to think about the order of cells or things like that. But if you stick with when the exchanges started to open, you go all the way from a mouse to something that is actually bigger than an elephant. My son in the video says it's some kind of a dinosaur, I don't remember which name, of a huge bigger dinosaur that is even bigger than an elephant. So all this growth through all these scales, all these type of animals, he did it in this very regular fashion of being scale invariant. He didn't care. It just the time became longer and longer, because as you increase the price, you need to increase the scale of time. It's simply, he will continue to do that. If he doesn't, then something crazy is happening with Bitcoin, and we will have to look at and see what happens. What is that thing? And some people say, what about ETFs? Are these one of the things that can change the nature of Bitcoin? No, I actually went and calculated how big of income or inflow we need to continue on this path, right? Because you can extend this prediction, and I have some of the predictions here. By the way, in my app, in that app that I told you, can actually show how it looks like. So if it is linear, in a linear chart, Bitcoin kind of looks like this, with these bubbles and this general growth, right? But you can extend Bitcoin growth in the future, like in this graph, for example. And here I'm comparing it with silver, and comparing with Amazon, with Microsoft. So let's say you want to go all the way to gold, right? To the market cap of gold, basically $15 trillion. Bitcoin will be about $1 million. And it's going to take about 10 years to do that. So it will happen more or less in 2032, something like 33. So this is when Bitcoin will be like $1 million. And because you can use this equation to extrapolate it and go to that date. And the idea is, you see this, by the way, here I'm comparing the growth of different assets. You see how very different they are. First of all, look at magnificent Bitcoin. These are gains, right? Gains that you made by investing in Bitcoin versus anything else, And look how amazing Bitcoin is. It's like really Godzilla in comparison with anything else, right? And they don't look like power law. They don't look like straight line. This beautiful, regular, amazing straight line that you see. It's not what the other stuff was. And you know what? Most of this growth that you see from the other assets, it's inflation. Inflation is so big with these guys that it's actually dominant. I did some graph where I plotted inflation, and like, for example, this SP 500 barely goes above inflation over this period of time. So it does barely beat inflation, but not even much.
Rick, can I throw a random question at you? Have you ever done this with political corruption and like the price of something versus how corrupt the government is? Because this is like, that's all I keep scratching my head. I go, can you predict when our government's going to like Go full
Yeah,
on
it will,
Nazi
it
Germany
will
based off
it
of
will be
this skill?
interesting.
What's the power law on a corrupt government?
Right. Yeah, it would be cool to check something like that. But you see, look at this, how beautiful it is if you actually average the price. Because in this model, see the straight line, the green line is a power law, the simple power law, just the simple formula. But then because I wanted to include the bubble, I started to actually add a little bit, because this is how we do in science. We started with a very simple model, and then we say, okay, let's add, some additional thing, right? I don't understand. I want to understand how air is affecting the fall of an object. I want to understand
Yep.
what happens if there is wind. So I wanted to add the bubbles, and so I have a model where I add the periodicity of the bubbles, because they are very precise oscillations that are happening every 4 years. I added this floor of the bottom, so these are very precise deviation from the trend, and then I actually also added this decay of the peaks, because the peak seems to go down in a very precise fashion. So I have even a formula for that, and look at what I get. It's Bitcoin, right? A very simplified drawing of Bitcoin, but as a model goes, it's almost astonishing, right? And remember, I don't model the first bubble because it was like a kind of an anomaly, but all the other bubbles are there, and I can then extend the model in the future and say, okay, if everything stays the same, if these bubbles continue to behave like they behave, if the bottom do the same thing, then we can extend it in the future. And I'm pretty confident that if Bitcoin continues to be a scaling variant system, that it did it for 9 order of magnitude, it did it for 15 years, can it continue to do another order of magnitude? Because I know it sounds like 10 years is a big time, but if you're thinking in terms of change of order of magnitude, it's just another change. So I did 9, can I do another one and continue to do it in the same way, right? My answer is yes. This is what the theory predicts. And if doesn't happen, then there is something wrong with the theory, or maybe there is something wrong with Bitcoin. Maybe there is something different, because I was telling you about the ETF. ETF is exactly what we need to continue this path. So to go to $1 million, Bitcoin needs the kind of inflow like the one brought from the ETF. In fact, you can almost put it on his head. You can put the theory on his head, and you can say, every time Bitcoin needed something to go to the next step, it kind of attracted it. So when we were over there, where Satoshi was kind of with his own little cryptography friends, they come in and started to bring human capital. They started to check the code, find bugs, run it on their machines. That when they created a little, Bitcoin talk, and more people came in, they started to do the first USD transactions. They started to started to appear about Bitcoin. We started to have Mt. Gox and Silk Road, etc. Every time Bitcoin went to the next step, something happened that, like this feedback loop, right?
It's an anomaly, something
attracted these resources that feeds the loop, in that beautiful loop that I
in
showed
the
you.
perfect timing, perfect opportunity had to
Perfect
happen.
time. So exactly. And so ETFs are the exact thing that Bitcoin needs to go to the next step. It's not an anomaly. It's exactly what is needed. And one day when it will be 5 million, 10 million, there will be some big event, like you were saying, maybe the governments give up and say, okay, let's get the Bitcoin standard, and we win the battle, and at that point, you will not have a power law because everything is in Bitcoin, and so but this is basically the path that Bitcoin choose, because this is how I want to think about this. Bitcoin is such an incredible intelligence system. Basically, it's us, right? All of us that are putting human value, the beautiful algorithm that Satoshi created, the difficulty adjustment, all these things interact together, and our desire to be free and be sovereign and independent, and all these things interact together and show the true beautiful knowledge of freedom. And this freedom, it's an equation. It's an equation that it's a power law that is planets and organisms and all the beautiful thing in nature use to find the optimal path to something. So this is the optimal path of Bitcoin, and it's not going to be broken, because this is what Bitcoin is. And if it is broken, of course, the theory needs to be falsifiable. That means it can be proven wrong. So,
Yep.
if it is proven wrong, then we will have to reconsider. You invite me to your show, tell me, Giovanni, what we do. We learn something.
Yep.
Right? Because it's still an attempt to understand scientifically. It's not
Absolutely.
that I am an idiot, etc. I still try to understand. There is something there for sure. And this allows us to try to understand this kind of thing. So it's still a tool that will tell us something went wrong. Like you can see right now, for example, this blue line is deviating a lot from the red line. Why? Well, probably because of FOMO. Sorry. There was a lot of excitement about AVTF. People don't understand scale invariance, so we got all excited. And right now the price is going down. Kind of. I don't think it will go down all the way to red. Maybe something in between, and then it will continue to go up and do this usual thing that it does. But there was a little bit of FOMO. The same thing when we had the COVID. We were excited. Then there was this drop of the price. It arrived to the bottom and it bounced back. But in general, this is the general behavior of Bitcoin. And the theory, what the theory does, because a good theory needs to make a very strong prediction, otherwise it's not a good theory. The theory says, no, it will continue to do this, and it will continue to bring on resources as needed to go all the way to where it needs to go. Is it 1 million? Is it 10 million? I don't know. On a certain point, of course, it needs to break, because, it cannot be more wealth than every single thing in the planet, right? But there will be a point where it deviates, because, we get the coin standard, the governments at that point, no small government, but much government decide to adopt Bitcoin. But this is what is supposed to happen in the future.
Let me ask you this. So taking a look at something like from a technology, like I assume you could apply this to a lot. The question I have is, Bitcoin becomes, like you had kind of said, like an IQ test. Like the smart people, it's attracting people. You have the ability to track the wallet adoption, and my curiosity goes, at what point do we get to a point where, like, wallet adoption is similar to the internet? Like, I mean, we had this similar adoption curve on the internet, but then you hit like an inflection point where, like you said, like the entire world starts to adopt it. Is there any way that this kind of predicts some type of model? Like at some point you kind of get to a point where there's going to be so many wallets that it makes up a percentage of the world. And if a percentage of the world is using it, then you almost go into like a hyperbolic adoption mode. Is that,
it could happen. And it's a good hypothesis. But my understanding right now, by looking at the data, is that if that was going to happen, it will have already happened. Because I know it sounds we are very, very early, but this is why you have this power law versus, because you can recognize, if you look at the mathematics of these curves that we mentioned before, the S curve. The S curve works like that. It's very slow in the beginning, and then it starts to go very fast. But it doesn't look like a power law. So if you plot it, you will get something that you can almost recognize it immediately. In fact, that is what I was trying to do in the beginning. One of my first posts on Reddit, because instead of publishing on a paper, journal paper, I will publish on Reddit, because I wanted to reach other Bitcoiners. I have a model where I use the S curve. I take the addresses and say, okay, let's try to fit it. And it was like trying almost to take, a square peg and fitting it in a round hole. I couldn't do it. I kind of was doing it, but I was getting really bad fitting. My model didn't seem to work very well. It was like an attempt, right? Because this is what you do as a scientist. You play with stuff until you get it right. And then I got this huge breakthrough when I saw that beautiful adoption curve that is a power law. And then I struggled myself. And I want also to show you something else. I went back and I created a little toy Bitcoin. And how did I do it? I did it where I have basically I make a simulation of almost like heat that is diffusing through a metal, through kind of almost like a chicken wire. And the chicken wire represents the network of people. So every intersection of a chicken wire is a Bitcoiner, right? And then the heat represents the spread of this information about Bitcoin, people getting orange peeled. So you can do that, like you can write equation to describe this little toy model. And then the beautiful thing about the computer, you can run it, right? You can do it million times simulations. You can go sleep and wake up in the morning, and this thing has done millions of times to try to see what happens in average, right? What happens in average is what you see on the left. So my little model of a chicken wire with the heat that is diffusing, representing, the orange peeling of people, is this. Okay, look how the real data on the right looks like. Do they look similar? And remember the exponent that I told you, the exponent, it's like almost a fingerprint. For the simulation was 2.85. For the real case, that is addresses, is 3.18. Then you go down and you apply this Metcalfe law. Basically, I look at many connections there were, many of these little wire were affected by the spread of this heat, and I get this second panel. Okay, this is the relationship between price and the number of Bitcoiner. If you think about these little nodes in the net representing the Bitcoiner, look on the right, the real data. Do they look similar? Very similar, right? Remember, I don't simulate the first bubble. I ignore the first bubble. All the bubbles are there, right? You see how crazy it is? And this is just a fake Bitcoin. I made it's a Bitcoin that is in my computer. And so look at this, and then finally the price. I reproduce the price from this, combining these two things, and you see how the price, of course, is much smoother and linear because it's just a simulation, and real life is more complicated. But look how all the bubbles are there, and here I got 5.71. When the computer runs, it gives me all kind of crazy, 5.8 or 5.9. I, by almost like a joke, I put 7. I got one that gave me exactly 5.71. There were like 1,000 and 1,000 of them, but all around this number, right? But here I pick one just to make a point that I can get the exact Bitcoin behavior, right? And you see how incredibly, so it means that we are really crack the code, that it is not as adoption. There is like a process that works in a very precise manner that can reproduce the behavior of Bitcoin. So this is a unique and incredible that, it needs really to be understood. So I don't think it will go to that place. It could be because maybe I'm missing something, there's something I don't understand and whatever. But right now, it looks like Bitcoin really settled on this thing. It really likes, remember, it kind of tried to find like an optimal path. And it says, you know what? I like to be adopted, but I want also Bitcoiner to be aware. So the process is going to take its time, people, because even when we go to crazy number, I think people will still need to think about what they are doing when they join. Now, during the bubble, it goes crazy. Some people jump in because of, their friend does it or whatever. But many of these people leave, when the price crashes, when they don't come back to Bitcoin. The long-time holders are people that are, they are really convinced. There is some kind of conviction there, and that requires awareness. And with awareness, makes the process fast, but a little bit curbed. And Bitcoin, for some reason, the system for some reason says, you know what, that is really what I want, because I have this very difficult task of becoming the monetary system of the world. I want to do it in my own way. Don't Giovanni, whatever other person, don't tell me what to do. I'm going to do my way. I'm Bitcoin. I know what I'm doing. This is how I'm seeing. This is how I understand it. And so this is why I don't exclude anything, because as a scientist, we need to be open to any possibility.
Absolutely.
That's within reason, But at the same, this is why we want to collect more data. We want to observe. We want to continue to study. I want to create, at a certain point, like an institute, to study Bitcoin like a science, and bring more talent and more people studying this thing, like if it was like a real scientific topic.
But I think it's the greatest technology in all of human history. It's one of the coolest and most technological advancements in all of mankind, and having the money and resources and a team behind it to study, I think would be one of the most impactful things that you could do throughout human history. Probably the most scientific study because it's pure, it's truth. It's the first real thing, the real raw, honest,
And
no fudging the numbers. It's just math. It's just simple
yeah,
fucking math.
exactly. This is why when I have debate with other people, they say, oh, like for example, there is this big debate, which is a little bit controversial part of my talk, right? Many people think that we are running out of Bitcoin, right? There is this thing, oh, we're running out of Bitcoin because they think that, there is all this pressure. And I have many, many slides, but let's see if I have a slide that has to do with what I'm trying to say, right? There is this big debate about, is supply an important thing, right? First of all, let me say that, of course, the fact that Bitcoin is not dilutable and it has a fixed supply, it's one of the most fantastic characteristics of Bitcoin. It resolves the problem of printing more Bitcoin, or making dilutable, people fighting how much Bitcoin we need. Satoshi decide we have this number, this is what it is, no debate, right? It cannot be changed. And so I will never debate that validity and importance of that characteristic of Bitcoin. But, many times people started to say, well, we are running out of Bitcoin because more and more people are holding on Bitcoin. And then, all these ETFs are coming. And so I don't like that narrative from a philosophy point of view, because it reminds me almost like Black Friday, people fighting, or toilet paper running out, during COVID. And I don't want Bitcoin, I don't want to imagine Bitcoin like that, people fighting over a finite resource. To me, Bitcoin is both finite in the sense it has a finite cap and infinite, because it can be basically feeding the world, right? All what you have to do, so being an Italian, like the pizza analogy, right? People say, oh, but it's like you're saying, you can cut a pizza and you can feed the world if you make more slices. Yes. And you know how you can do that? By making every slice more nourishing, right? If you every small little size has more and more value, one slice is $1 million. Now, of course, you can nourish everybody, right? This is how you can do this beautiful magical trick of being something that is finite, but also it can do this task of feeding the world, of being the monetary
getting more value with less
and
coins.
Yeah, exactly. So you give more and more value. So if I'm a crazy scientist and I give you a small little slice of pizza, and that pizza can feed you because it has so much nourishing power, then I solve the problem of hunger in the world with one pizza. I can do it, and you have to do it in the right way. But this is what Bitcoin is trying to do. So when people tell me that there is some kind of a supply crisis or supply crash, I go and look at the data, because I can have whatever philosophy I like. I don't care what my philosophy is as a scientist. I have to throw it away if the data shows me otherwise. And the data, there is no one single piece of data where I see a supply shock. There is not, because what happened, for example, in this graph, right? The beauty is this: you can go and look at things that are related to supply. For example, the number of long-term holder that you're seeing here in this blue curve. And you can see that what happens during the bubble, they grow up, we have more and more of them. But when at the moment when Bitcoin is supposed to be the scarcest, or when everybody wants Bitcoin, they are starting to sell, and they are going to be smaller, less and less. The long-term holders start to sell. They sell all the, like, it turns out about 60%. 60% of the long-term holders sell their coins or part of it. And then what do? They buy at the bottom. And this is good, because we want Bitcoin to be also liquid, and we want other people to share Bitcoin. How can we have adoption if there is somebody that doesn't sell Bitcoin? If everybody holds Bitcoin, how can we increase adoption? And I just show you the data tell us that the price goes up with adoption. So it's all positive in the sense that, and adoption is very different from demand, because demand is basically, okay, I need this thing because it's fashionable. I need this grape because I'm hungry, or whatever, But adoption is a different thing. You need to adopt the technology, you need to understand it, you need to use it. It's a different type of mechanism. And it's beautiful because it's not competitive. More people adopt something and the price goes up. It doesn't mean that I'm competing with these people. In fact, the reason why the other side of the equation is, okay, adoption goes up with the cube, but then Bitcoiners square gives the price, and that square, that advantage that we get by being more of us, we get it because more of us can interact with each other, and we are going to have more exchanges like this. Okay, I sell, you want Bitcoin, I sell you a little bit of Bitcoin. We have more interactions in the network that increase the value itself of the network. So there is no competition. It's not about competition. It's about collaborating and working together. At the same time, the fact that we have a finite cap avoids dilution. So you can have both. It's one of these things where Bitcoin has all the characteristics of something that seems almost like opposite, but they reconcile these things. So I don't like a little bit that rhetoric with some of the other data analysts. I don't know where they found it, because I don't see anywhere in the data where it shows that for some reason we have some kind of a supply shock or reducing. For example, you see here this orange line, it shows what happens with incentives. They stay constant. And this is due to the fact, because maybe if you want to follow me for a second, it turns out, right, that every 4 years, the machines became more efficient because of Moore's law. And so Moore's law is what this empirical law that says that every 2 years, the power, the efficiency of computer goes by a factor of 2. So in 4 years, they go up by a factor of 4, right? Now, it turns out that the system, the Bitcoin system, regulated itself, where price and hash rate are related by it's like hash rate equal price square. So, or price equal hash rate to the square root. So you lose a factor of 2 in this increment of the power of computers because of the price, the hash rate that you need to increase the price, right? But what happens then, there is the halving rate, they cut that by another factor of 2. So basically the total result of the halving is that you are not punishing the miners, but you're not also allowing them to use this advantage due to the Moore's law. So basically it's kind of like a balancing effect. It's like a thermostat. And I don't know if Satoshi did it on purpose, or like many geniuses, you do something, you tinker in something, you put something there because you think that it's important to have this controlling mechanism. And then the system regulates itself, where it creates this relationship between price and hash rate, where everything turns out to be stable. And this is where the orange line comes in. Basically, it's telling you that just before the halving, this is where this vertical line is, you're getting a little bit more incentive because of this advantage of better machines. And then the halving cuts that and brings it back to
checks
stability.
You right, puts you right in your place.
Right. Okay, you can do, because basically it's an arbitrage kind of thing. The miners can make a living, a very good living, but it's never like a free lunch, right? And if you allow the Moore's law to go unchecked, they will have a free lunch, and this will have been broken long time ago. And instead, the genius of Satoshi, or the genius of Bitcoin, it's regulating itself. It's like a thermostat. You see? And so it doesn't have anything to do with scarcity or having less Bitcoin, because really this change in supply in particular now is so small in comparison with the general flow of the market and the volume of the market. It doesn't have really an impact. It's important for the miners, but nobody else. And so really the bubble, my theory, and if you go in you watch my son videos, this is a series that we have, but also my article, I explain it's almost like Christmas, it's important. It's a ritual, right? In Christmas, we celebrate the cycle of the year. There is the longest night of the year, and then there is the sun. This is why we are associated with Jesus, and it was a pagan holiday. Then Christianity took it and made a connection with Jesus, because it's the light of the world, all these kind of things. And it's an important celebration because humans are also symbolic, are also, for us, rituals are important. So basically, it's like a Bitcoin Christmas in a certain sense. And so people get excited, and it's useful. It's not like a stupid thing, because all this excitement brings innovation. There are many new companies associated with Bitcoin. We offer services. New Bitcoiners are coming in. Some leave afterwards and don't come back, but a lot of them also stay. So it's an important process. It's almost like you're seeing this. We use this analogy in the video. We say you see this beautiful city being built, and there are all this activity happening, all this upgrade of machines and everything. Even if you don't know, you know that something is associated with this event, and you see all this activity and say, okay, maybe I should go to that city. Is where everything else is happening. We have new bridges, we have new houses, we have new schools. Let me go there, and then you became a citizen of this new city that is growing and is having more value, more activity, more connections. And so this is what is happening. And it's a beautiful story because you don't need scarcity, and again, I'm not against the fixed supply. I'm saying scarcity like we're running out of Bitcoin, because it's all about value. It's all about positive things like adoptions and more Bitcoiners and
we're saying,
amplifying. More of us, the merrier. It's about collaboration and being a network.
Yeah.
And interchanging.
When you have scarcity and money, you have abundance of everything else. So even though there's fewer Bitcoin on exchanges, there's the value of it's worth more. It makes total sense. I understand.
Yeah, exactly. So it's all about focusing on all the good things that are associated with Bitcoin, like having more Bitcoiners, having this network property that amplify, because it's not just going up with the number of Bitcoin, it's going up with the square of Bitcoin. So you double. You bring 2 friends, you get 4 times the value. You bring 3 friends, you get 9 times the value, and so on. It's beautiful. And this is why this theory, I think, it gives much more than just being like a model. It gives you like an entire understanding about Bitcoin. And if it is really true that it's the scale invariant system, it makes it similar to planets. It makes it similar to how biology works. It's like, wow, when we go to people and tell, okay, why these assets is different. Well, I don't know if you can make this story as simple as one sentence, but you can tell them it's different from everything else because it's basically like a law of nature. And I know that maybe people will say, what do you mean? What do you mean? Yeah. There is this crazy scientist and other scientists, we found out that it's very regular and it behaves like a planet. It behaves like an organism. It's different from everything else, So it's very predictable, and these oscillations are also predictable, and so you actually can plan ahead and say, okay, I'm going to buy here, I'm going to sell there, you can do all these kind of things. It's very powerful, very, very powerful.
It seems like, how many would you say different data points have you? It seems like everything I'm asking, you've had somebody ask you it, and then you've went back and tried to use this or compare this. Like, how many different inputs are you actually monitoring to come up with your overall thesis here?
Well, so there are all the days, right? And you could use hours, etc., but it's not worthwhile. So I'm using all the days. I also try to go back to the first original transactions. I found them like maybe 6 or 7. I included even the first early transaction ever, where one of Satoshi friends sold 10,000 Bitcoin for $1, and I put it there in the graph, and it actually falls on this power law, that early transaction. It's very close to the power law. It's like almost crazy, and then you have hash rate, and then you have addresses, not just addresses of one type. I showed you all these addresses. I can take, 0.1 Bitcoin, 0.2 Bitcoin, 0.3 Bitcoin, and they show you all. There is this very regular pattern that I can actually. Fred one time made a video where he took the value of these exponents and he put it in a log graph. And guess what? Even these exponents of all the different addresses, they form another power law. That is, again, we call it multifractality. When you have power laws of power laws, it means that you're really going down the rabbit hole. It's almost crazy, right? It's like, oh, you know what? There is an article from this scientist. It is one of my favorite scientists. He's also a physicist. And he wrote 3 different articles about Bitcoin. And he's a physicist, and he published in a real journal. And one of the articles is about holding times of Bitcoiners, how long a Bitcoiner holds in comparison with how much Bitcoin he has. Guess what? That is also power law. It's crazy, right? Like, okay, so, there is actually, I found a shirt online that because we use so much power laws in physics that we have almost like an internal joke, right? And so this guy made a shirt that says, I went to physics conference, and
Yeah.
what I got was a lousy power law. And I modified it and I scratched physics and I put Bitcoin conference because I'm applying to go to the Bitcoin conference in Nashville. I asked, can you let me talk about all this because it's so interesting? And if I do, I'm going to present with that shirt. I'm going to get
Oh,
me that
that's
shirt
awesome.
with
That's
a
awesome.
scratch. All what I
Yeah.
got
Yeah.
from the Bitcoin conference was a lousy power. No, you actually
Yeah.
get 6 of them, or
Yep.
7 if you include the holding time, and the
Yep.
power laws of power laws, and it's all
Yep.
power laws. But it's beautiful because it tells us that really this asset is something different. And now we have a math, we have a physics, we have a science, and I want to publish because if I publish, it's not that scientists are these privileged people and authority, etc. It means some other clever people, look at my data, maybe give me some feedback, or maybe tell me, Giovanni, you need to do this better
No, I think this.
calculation. It's like a pushback, right? But it's very encouraging that Fred likes it, and he's not a stupid guy. He has, he has applied math in the
Yep.
environment of finance. These scenes that I told you, he did all these tests of stability on the power law. It's a real thing. It's a real thing. Now, I am a little bit more poetic than them and try to tell all this story about the planets and the organism, etc. Because really, it's not me that just makes that think. If you read this book about scale that I told you, that when you have chance, please read it or listen to the audiobook when you do something else, etc. It's really nice because it shows you how they come up with everything, like different political situations. Like you can study how terrorist attacks are happening. I don't know if I did it with corruption, but we should try. We should look at
Yeah.
corruption in people. All kind of things like that. There are
You
these
could.
very precise behaviors because maybe we do have free will. I believe in free will,
Yeah.
but at the individual level, right? When we
Well.
start to interact as members of a large community, there are all these very precise laws that explain how we do interact with a lot of noise because we are still
Yeah.
humans, and there are unpredictable things like COVID and so on. But
Yeah.
even in COVID, in predictable things, you saw how Bitcoin
Yeah.
handle it because it has this ability of being self-adjusting and
Mm-hmm.
self-protecting and so on. So like almost homeostasis. So it shows that really Bitcoin is something different. It's something unique. It's not like Nasdaq. It's not
Mm-hmm.
like gold. It's an intelligent system. And if the math is shown that is correct, and we continue to see the data behaving in this way, then it's really, it's beyond that, like being an analogy or a nice metaphor. It's science,
Mm-hmm.
and it's amazing. I find it
Mm-hmm.
amazing and beautiful.
No, I really do. I think you could measure. You could probably measure corruption based off the debasement of a currency,
Yeah,
right?
yeah.
You know what I'm saying? I really think you
Exactly.
could put a. Is there any power laws out there on the debasements of currencies?
So the basement of currencies usually they became like exponential because it's really so. See, that is the other thing that this Jeffrey West talks about. He showed, for example, a lot of companies they behave like in an exponential fashion. They grow very very fast,
Mm-hmm.
and then what happened to them? They die. And he has this saying that he says, "Cities are eternal, companies die." And cities behave like power laws because power laws, remember, it's about stability, it's about anti-fragility, it's about protecting themselves. So cities tend to behave like power laws. Companies that are useful, but there is a lot of corruption in companies, particularly when
Mm-hmm.
they became very successful. There is a lot of a political, there are political gains that are happening
Mm-hmm.
inside companies, different type of, the administration takes over versus, like they fire, um, Steve Jobs, and it is the creative mind, and some administrator comes and say you're fired, and then they hire him back. All these stupid political games they make it behave like exponential. And so exponential, like cancer, is associated with death. Things that became exponential. This is why I don't like Bitcoin to become exponential, because to me will be being associated with something that looks like that. Things that grow exponentially, they grow very fast and looks fun and exciting. But if we care about the long-term growth of Bitcoin, we should not want Bitcoin to be an exponential. We want it to be a power law, because it needs to be like a city. City are eternal. Look at my hometown. I'm not from Rome, but the capital of my country, Italy. I'm Italian. Rome is there. We call it in Italy, we call città eterna. It means eternal city. It's there since 3,000 years. And Jeffrey West, the scientist that I mentioned, he talks about Nagasaki and Hiroshima. They nuke these cities. They're still there. You can go today and travel in Hiroshima. It's actually a lively city. You can nuke a city and it will survive. Companies die. In fact, there are not many companies that are older than 100 years old. Almost all of them died. And corruption, if you are saying, very good observation, inflation, right, or debasement, etc., it goes like an exponential, because it's something that basically goes out of control. So when you have an out of control process, it becomes exponential, and then this is why it goes bad very quickly. And so that is one thing that you can use the power law theory to say, okay, if it is not a power law, probably something bad like an exponential, and this is why you can associate it with things like corruption or debasement or inflation. Inflation is an exponential. You look at like the Argentinian pesos, it becomes like an exponential. So it's beautiful that Bitcoin is a power law versus an exponential. It's actually tell us that Bitcoin is this stable growth, beautiful growth, because at 10 to the 6, remember, you're just sitting, you look very young, for you 15 years is nothing, right? You wait 15 years, and now you get, just by holding, not even playing these games of selling at the top or rebuying at the bottom, just holding, it will give you a 64 return. You wait 30 years, that is 3 times. You know what is 3 to the 6? 720. So you will get 720 returns if you can wait 30 years instead of 15. 15 gives you 64. 30 gives you 720 times. Not percent, times.
Yeah.
There, So 64, it's take Bitcoin 60,000 now, times 64, that is about $3.6 million. So in 15 years from now, Bitcoin will be $3.6 million. It's amazing, because compare it with anything else, right? NASDAQ or SP 500, whatever, like you get 5% a year, we're talking about 64 times in 15 years. It's still that crazy, because of course it will have been better to join in early, because of this scaling. It means that it takes longer and longer time to go up by a factor of 10, but there is still so much room that we are, in a sense, still early, because and if you told anybody in the history of mankind that you can make 64 times your money by doing nothing, just holding something for 15 years, that is a relatively short amount of time, even for an old guy like me, it's amazing. It's life-changing money. If you have a
what is it in 2050? Do you have it out to 2050?
So 2050 will be 30 years, right? More or less. So let's round it to 30 years.
Sorry, 2070. 2070. Can you go to 2070? Because I have some. I know the value of what a house will be in 2070.
So that is what we can calculate it.
50 years.
Because
50 years.
I would not be able to do it in my head.
Well, give me 50 years.
Yeah, give me a second. And I go back to my nice little app.
So I'll give you, while you're looking it up. So in 2074, at the rate of inflation right now, the average price of a single family home, just like a basic 3-bedroom, maybe a 1-car garage on a basic half-acre, quarter-acre lot, just your basic average medium house in America, will be $6.8 million. The average automobile, right? Your first car will be 800, like your basic Ford Focus with like roll manual windows, no electronics, just your basic average car, will be $892,000. So I'm just curious on like right now,
Yeah,
your
so it's
dream
kind of
house
a
is
crazy
probably
number.
5
It's a
Bitcoin.
crazy number, right? So
Yep.
if you're talking about so 50 years from now, that is a total
Mhm.
history of 65 years, right?
Yep.
That will give us $290 million for one single Bitcoin.
No, that
And
makes
so at that
sense.
point, at that point, and that without that is without including inflation, right? So I mean,
Yep.
it will be whatever equivalent Bitcoin is, whatever equivalent to $290 million will be at that date. My understanding about that is before we arrive to that value of Bitcoin, we will adopt Bitcoin. And,
Mhm.
Bitcoin will be adopted as the standard.
But would
And
that
at that
be
point,
so would you think that that would be I mean, that seems
I
like
think it will
if
take
like
20 years. I think it will take 20 years, 20, 25 years. So
but it would
by
still
the
make
time,
your power law right if it went right to
no,
300 million,
will
right?
disappear. It will disappear because we don't use dollars anymore, right? Dollars doesn't, it's not used anymore. It will be pegged to the Bitcoin, right? So in that case, $1 equal one Bitcoin. Or people will not use $1 anymore. So
So you think
um,
they completely forget referencing it in dollar value at some point?
it has to be. It has to be where we
How
basically,
would that
or,
so what would we
we
do?
peg it, right? We peg it where becomes like gold, right? You say this amount of dollar is equal to this amount of Bitcoin, and it will be stable, right? That is the entire idea of a standard, because this Bitcoin basically, this power law is the history of Bitcoin becoming the monetary standard. Once it
Mhm.
becomes the money standard, it's like
Yeah, I see what you're saying. Yeah.
there are you have some of the graphs where I can show you, like for example, I have this graph in my slides where I show you the power law of the growth of a task of an elephant, right? Well, that power law goes, okay, here,
No
this one,
shit.
you see it. This is the growth. You see the pink one is the female, and there is this entire article that is a beautiful article. They found these power laws in horns, uh, in the tooth of animals, in thorns of plants, in all these processes. And here, there are all power laws. And this is the power law of a growth of an elephant tusk, the size versus time, the age of the elephant.
Mm.
And the female has one power law. It's a little bit, slower growth. This is why you see the slope a little bit swallow, right? A little bit
Mhm.
smaller slope. And the elephant, because the male has bigger tusks, it goes faster. But you see, you can almost like by the growth of the animal, you could determine the sex. Okay, I follow
Yeah.
growth of this task. Okay, this is a way of telling, or maybe different species. Different species will have different rates. So these are how important these power laws are. But you see, at a certain point, the task doesn't grow anymore, right? So it stops growing because there is some mechanism that say, okay, after this size, it doesn't
Yep.
go bigger than this. Like even humans, right? We grow
Mhm.
with a certain rate and then we stop, right? There are mechanisms inside the body. If you don't stop, there are some illnesses where you don't stop, and that is actually a problem. It's part of having this kind of gigantism or whatever it's called, this kind of illnesses, this kind of genetic defects, right? So I think it will happen like that, where at a certain point, the growth is so big that basically there'll be one of these events where a nation like the United States will say, well, let's peg the dollar to Bitcoin. And when you do that, then of course this growth will stop, right? Because at that point, there is no change in one quantity versus the other. So this will be when Bitcoin finally did this task of growing up to this adult, to this creature that is the monetary system of the world. So that is how I envision it. But it's a long time, so let's take it 10 years at a time, and see what
Yeah,
happens. We can still
absolutely.
speculate and try to understand, because I'm actually writing a book. It's called The Physics of Bitcoin, and I have a final chapter where I'm trying to speculate what happens, how this process ends, what is the end
Yep.
scenario, what is the end game. But it's, you go from science to science fiction, like you can still try to do science fiction and trying to do, kind of science-based science fiction, but it's a little bit like science fiction, because who knows what happens. I mean, differently uh, from Bitcoin, that is a power law, technological progress is also exponential. And it's different also. It's very interesting because I told you that exponential die. What happens with technology is that they don't die. They don't die because technology doesn't die, because there is always some kind of paradigm shift. Like, for example, we went from using vacuum tubes to transistors, and that allowed this exponential growth to continue. So if you look at how technology works, it works like this. You see this hockey stick that is exponential growth, then it stops, and then there is another hockey stick that is the new technology that takes over, and then there is another one that takes over. Multiple processors, and you get up and up and up and up, and that process, it's like super exponential. And so in 20, 30 years from now, are we going to have AI that is going as clever as human beings? What that AI is going to do, I don't know. I have no idea. And so it's like, this is why I like to make a prediction that is something that I can stand by. So I did it with you, to play along the projection of 50 years from now, but I will not trust it. Like 10 years, we can say, okay, it's probably very, very strong prediction because of this scaling variance. It's just one order of magnitude. Unless something catastrophic happens, Bitcoin should continue to behave in this way. 20 years, we are stretching it. By the time we go to 50 years, we are going to science fiction territory, So let's see what happens. Let's have these episodes with you every 4 years, and maybe more often. Often I can talk with you, because, by the way, I really compliment you because you have been so patient and you ask so many beautiful questions. I really had fun. I say more things and more interesting things because of you than any other interviewer that I had so far. So I really want to compliment you for being so patient and some listen. I can feel that you're following along, and I really thank you for that. It's you gave me a great opportunity of explaining the theory. So I'm very grateful. Also because I am a night owl, and my brain works better when I have interviews at this time rather than early in the morning. So
I guess it was meant to be, my friend. It was an honor to have you on. And like I didn't tell anybody when we started, but like last year, it was probably like 3 or 4 weeks ago, you were going to come on, and I had the show, and you thought it was at a different time, so we missed each other. And then this week I didn't have it scheduled out, but I knew I had the interview, and I got done with my show at 3:00, and I was like, okay, I'm going to edit some videos. I'm going to do some stuff. I got this show tonight, and I'm getting busy. I'm editing. Next thing I know, I'm looking over. I go, I see your message from you. You're like, hey, man, can we reschedule? It looks like I missed it. Like, I'm not getting the link like I was supposed to. And I'm like, oh, shoot. So we threw it up real quick, and I'm so glad we did, man. That was such a great stream. So really, thank you. No, but what I was thinking is, if you get this published, right, and there are people that maybe add to it, or they have something to, contradict it, and you guys want to talk, man, I would love to have both of you on the show. And have you guys go back and forth.
Maybe, we can have what we could do. We can come together with, we can have like a group talk with Fred and these other guys.
I would love to do that.
Fred has also another astrophysicist that he discovered the power law independently from me, after me, but he basically redid the same discovery. That is another good sign, right? Because if there are more people that are discovering the same thing independently, it means that there is really something there. And so, we are all agreeing that we are looking at something here that is really meaningful and significant. So I think all of us will give you a different look at why this is interesting, what are the applications, how we can use it. So we can have another meeting, if you like,
maybe absolutely,
as we are coming closer to, because of a prediction. So basically, if people want to know, because another thing I didn't show, and maybe we can
go ahead. Short up, I'll jump back over there.
Here. I have this beautiful clock. I made this Bitcoin clock. So basically, what I did, I didn't invent these. There is this other analyst, his name is Rational Root. He came up with this idea, and again, is like I didn't invent I didn't invent the power law. So I use it to understand Bitcoin. He didn't invent this chart. It's called a polar chart. It's something that he used often in science, but he had a very beautiful idea again, one of these things that say, oh, why didn't think myself to do that, right? Because until somebody does it, that person needs to get the credit. He was the first one. So I want to give credit to him. But my contribution to this is actually to plot the power law, because he didn't have a power law. I have a power law. And the white spiral, so the blue is the price. So rational root had only the price and nothing else. And, the different markers for the price, for the time, and so on. What I added was to add the power law. And look how beautiful the power law is. It's this beautiful spiral that looks like maybe 3 rings or the shell of like a beautiful seashell, when you cut it like a nautilus shell or something like that. So it shows you how regular and how precise this pattern is. It's really a good representation, because you can see how the spiral hugs the price of Bitcoin, sometimes almost like unbelievably crazy precise, right? And if I average, like I have a graph where I average this price, it's almost like falling on top of this spiral. So the spiral is just an equation. You're looking at an equation. It's like a simple equation that describes the behavior of Bitcoin. And when you put it in this circular map, it becomes a spiral. Instead of being a straight line, it becomes a spiral. You understand what is going on there? Maybe.
Yeah, walk us through it though. Just so I make sure that I understand it. Walk us
Well,
through like the
basically,
first $10 dot,
how do you
the
go? How do
$10.
you go from the straight line to the spiral? Well, basically, what you do is this: you take the time. Remember, we say, and I have written here. I say rho. So rho is price in this case. Rho represents the radius. So how do you go from something that is like straight to something that is circular? Well, you for a circle, there are 2 important things, right? One is the radius, and the other one is the angle, right? And so some people think, well, so basically the angle represents time here. And so people can think, well, it's weird to think about an angle being time. No, it's not real weird. Think about a clock, right? A clock, when you, like an analog clock, right? When you have every 90 degree represents 3 hours, right? So you have a 90 degree is 3 o'clock. Then you have 180 degree, it's 6 o'clock. 270 is 9 o'clock. And with full circle is 12 o'clock, right? And then you repeat the cycle. But basically, if you transform, you say, well, I'm going from time to an angle. And in this case, because the periodicity of Bitcoin is 4 years, every 90 degree represents a year. So you see how I go from the top of a cycle to the bottom of a cycle. This is one single year. And this is represented by a 90 degree angle. And then the other 90 degree angle, so if I go from the bottom of cycle to when the bear market ends, so I call it the transition from bear to bull, it is kind of like what happened around the January of, last January is when we transition from the bear to the bull market. And then you have and that will be, if you think about time, this will be 12 o'clock, it will be 3 o'clock, the bottom of the cycle, this will be 6 o'clock. So right now, for example, this was done a few days ago. Right now it's 6:54. If you're thinking about time, it's a Bitcoin time is 6:54. When we reach 9, that is when the real bull market starts. And that is supposed to be kind of about 1 year from now, a little bit less than 1 year. So it's going to be like the end of 2024. So beginning of 2025, when we're going to have a full bull market. And then is another year of bull market, very frenzy bull market, and we reach the top. So it's very, very precise. Every 90 degree, that is basically every year, we have something very particular that is happening to this cycle. And so the way I get the spiral is that I use the same formula that we had before, price equal time to a 6. Here I've write it as 41/7. That is kind of close to 6, but we can put 6 there. So it's basically rho, that is the radius. So in this case, the radius represents the price. This is why you have a spiral, because if a price, like for example, I did it with gold, right? I have a picture like this with gold. With gold, you see a circle. And you know why you get a circle? Because basically the price of gold doesn't change. It does not change in the last 15 years, right? It didn't change much. So it became a circle. With Bitcoin, right, the radius is very small in the beginning, and then it becomes bigger and bigger and bigger and bigger. And this is why you have a spiral, right? So I have movies of this. If you go on my website, I have like a little animation of this where you see this end of the clock, right? The end of the clock shows the current time, and it becomes bigger and bigger and bigger. So the spiral is nothing else than this very simple equation where basically now time is the angle and the radius is the price. And so if you do that, then all of a sudden this beautiful straight line that we saw in the linear chart, it becomes this amazing spiral that you're seeing here. And you can see how the price really follow that spiral, right? Sometimes above, sometimes below, but in general, follow the trend of a spiral. And now you can actually project the spiral to the future. In fact, you could go, 10 years, 20 years, or whatever, and you can see what the price will do. So, this is what we try to do here. I need to correct this. You say top 195 is because I'm actually calculating the last point, and it should actually calculate it at the top. I'm going to fix it, but the top is supposed to be $220,000. And you see how they all happen in the same region. So, for example, you can say it's around maybe like 1 hour before midnight or midday, whatever you want to think. So it's about 11. So when you are close to 11 Bitcoin time, you're going to be close to the top. And sometimes it happens at 11:20, sometimes it happens at 11:30, but around that region. And then all the bottoms are happening around 3 o'clock. And so it's a beautiful. If you combine these two things of the overall trajectory and this very cyclic nature, and this is when actually scientists can make prediction. In these two cases, if you have something that is very periodic, like the orbit of the planets, this is why after 1 year we come back to the same place where we started, right? This is what happens with periodic phenomena. That is very predictable. And the other one is when you have the scale invariance, because we use scale invariance all the time. I show you with the elephant tooth, right? I can look at what elephant tooth growth was after 5 years, and then I say, okay, it's scale invariant. I make this little triangle bigger. Everything is proportional. I scale up of the time and the scale up of the size of it, and they can kind of predict what the size of the elephant tooth will be when the elephant is 20 years, 30 years, And in fact, if it doesn't follow that power law, then something is wrong with the elephant. Maybe there is some illness in the elephant, maybe some genetic defect or whatever, and actually could be used almost like a diagnostic tool. This is why with our power law here, if it doesn't follow the power law in the future, something is wrong. Hopefully something wrong in the good sense, that maybe there is something that makes it go faster, because it could, let's say that it follows the power law, but maybe now adoption goes even faster. Maybe it goes up with the fourth power or the fifth power. And so I'd want to be a power law, because power law has all this beautiful property. But, if we want to hurry up, maybe, they are called phase transitions. When, let's say you go from being a liquid to a gas, right? The system has this very abrupt change that we call phase transition in physics. So we could have a phase transition. Hopefully is a good phase transition, like in the sense that it's something positive for Bitcoin, and it's not like a catastrophic event, where actually Bitcoin goes down, instead of going up. But to be honest, power to the 6 is good. It's fast. Like in the Bitcoin standard, we talk about, preference time, fast preference time and low preference time, so Bitcoin is almost like teaching us that it's good to be a little bit patient, So instead of wanting to become millionaire in 1 year from now, like some of these crazy models predict, this model is much more, it's still crazy because, when you say price went parabolic, parabola is 2. This is 6. So it's a super parabola, it's a super parabolic move, but it's not exponential. And exponential, we say, are usually bad things, So it's what Bitcoin wants to do. So I don't have a problem. Whatever Bitcoin wants to do, I'm trying to listen to Bitcoin. I don't want to impose my own ideas to Bitcoin. Whatever Bitcoin decides to do. Right now, has done this for 15 years. It has done it since he was like a small little mouse, in fact, even smaller than that, all the way to this big dinosaur, and he's going to be Godzilla, and he's going to do it his own way, whatever Bitcoin thinks is the best path, the least resistance path, So let's see, let's collect more data, let's see what happens. But right now, I'm very happy with all what we are learning from Bitcoin, because, like I say, it seems that there is something magnificent, look at this, look how incredibly regular and precise this behavior is, and if he continues to do this and we get a Bitcoin to $3 million, $4 million in 15 years, I'm happy. I don't know you, I'm happy.
Well, I like the way that you're saying it, because I had this outlook from just like seeing people's tweets and comments on Twitter that it almost looked like it made it sound like that this was some crazy wacko theory, and it wasn't. It like you presented in a guise like, I'm collecting information and I'm sharing the information. I'm showing you all the correlations between the information and how you can use it to predict future price. And I'm not trying to tell you that this is guaranteed where this is going. You're completely open to the idea that this being wrong, and you just want more information and you want to share this information with everybody. And I think it's really powerful, and I think it's really important that somebody does information like this. So
what happened, Ryan? There was one of the other influencers, and he has a channel, and I understand it because I have my YouTube channel too. I don't like it too much, but some people like to make clickbaits, right? So they take a little snippet from an interview where maybe I was too enthusiastic, and they say, hey, I can tell you exactly when this happened. And what they meant is that the equation tells you an exact date, etc. Now, like we did it with $1 or $10, I can tell you the date, but Bitcoin, maybe the real Bitcoin is going to do that 10 days later, 20 days later, right? So it's there some randomness there, right? It's not that incredibly precise. And some people, even took I made like a little joke, like a self-deprecating joke on my website. I took a picture of one of these clickbait that says, astrophysicists predict exact date. And I thought it was like almost like people understood that I was making fun of myself, and people took that as, oh, he's selling classes where he teaches people the exact date. And I thought, how crazy people can be, sometimes. I don't understand it. It's human nature, sometimes people, see the first thing and they try to misinterpret what you're saying and so on. But you understand, right? It's exactly, I'm trying to be like a scientist. I'm fascinated by this phenomenon. I see this irregularity. I understand as a scientist that needs to be something real there, some precise mechanism. I point out what this mechanism can be. And I'm making a theory. And the theory says, well, if all these things connect, then this is the conclusion, and we can verify, because this is our science theory work, that if there is more data and it comes in, you never see scientists always correct people and say, oh, this theory has been proven right. You never prove right any theory, like even gravity. Like all what we can say is, well, we now made billions and billions of observations during human history, and every time we drop a stone, it seems to fall instead of levitating. But it's possible to miss something about the nature of reality, where there is some weird situation where maybe the stones start to levitate, and this is why we need to be open and try to accept whatever reality tell us. Like being a scientist is like exactly like with Bitcoin. You don't want to trust, you want to verify. This is why, for example, I made this calculator that I can send you the link so you can maybe put it in. People can play. I love when some of the people that know a little bit how to use like some coding, go and get the data and reproduce these charts. Like Fred at a certain point, he had a context. They say, okay, I'm going to put you like in a people that do stuff instead of talking list. If you do this chart that Giovanni did, go and get the data, use your skills.
You can train AI, right, to read data. Is that what you're saying? Like you can get really advanced models that do really crazy stuff.
Right. Even easier than that. Like, for example, if you have ChatGPT and you give it some data, because nowadays you can actually load up an Excel spreadsheet,
Yep.
and there is, like, for example, I use bitcoinity.org. You can
Mm-hmm.
get the price, and then you say, "Hey, ChatGPT, can you fit this data with a power law?" And look at what you get. I'm actually asking people
No
to do that,
way.
because that will be a really cool way for people to actually see the power law being made in front of their eyes, instead of me telling you that it is like this. Ask ChatGPT, and maybe will ask you. I don't know. Some people know, maybe in your audience know, to do Python. That is open source coding language.
Mm-hmm.
Ask ChatGPT to give you the code to do that. It's not very difficult, actually. If you have like some, like, maybe college level, maybe first year college level, high school level, like
Yep.
maybe good high school level, you can do it, because it's really not that difficult. We're not talking about quantum mechanics or anything
Mm-hmm.
sophisticated. It's relatively simple math. And that is the beauty, because in physics we like simple things. Um, simpler it is, easier it is, because it means that there is some very precise regularity there, that is something about the nature of the phenomena that you're studying, and this is why you don't want to make it too complicated. And
Mm-hmm.
so it's that is my attitude. And if this stuff is true, and it continues to be true, and you're adding more data point, and you can actually continue to follow that red line, it's magnificent. It's something like we never had anything like that in human history, where an asset can be predicted years in advance, and is behaving like how people will react. Many people, even now, after I tell them, look, I'm doing this for 5 years, I mean, it's not that I'm making it up, they still don't believe me, so okay, fine. There will be some people that use it, and they can use this knowledge to their advantage, because you could have both the bottoms, you could have sold at the top, if you follow this model, because you can use all the skills. We are developing all the technology, like I show you this graph, for example, right?
Mm-hmm.
So I look at all the deviations from the trend. So here I subtract the general trend, right? So you're seeing the percentage difference of the price of Bitcoin relatively to that general trend. And then I color coded the different deviations, right? So, for example, 50% is red, 40% is minus 40% is green. And so you can see, even if you don't have to be perfectly precise, even if you just add a rule, and you can do better than this, just as an example, that says, well, okay, when I'm red, I sell. When, if I do DCA, maybe
Mm-hmm.
I'm going to wait to buy. I'm not going to buy in the red area. I'm going to buy only in the green
Yeah.
area. Or, if you want to sell a little bit, let's say you
Mm-hmm.
sell 20% of your holding, and with the intention of buying back, because we always want to Bitcoin, you sell there. It doesn't
Yep.
have to be that precise where you get perfectly the top, but you can see that just by even something very simple like this, you could multiply your Bitcoin by a lot. In fact, I kind of made a calculation. Do you remember when I told you between year and 10 years, you will get $1 million in
Mm-hmm.
Bitcoin? So that is about what? A factor of 20, something like that.
Yeah.
Well, if you actually play this little game that I told you, and it depends on how precise you are, how close you get to the bottom or the top, you can get all the way to 300 times in 10 years. And so if you can use this knowledge, where you can play a little bit with these, and
Mm-hmm.
again, maybe 300 is too much, because it will be that you really get the top, you get the bottom. So, cutting in half that performance, maybe 100 times, so maybe 40 times, so maybe you do 2 times better than what you will do just by holding your Bitcoin. So because you want to be more moderate, maybe instead of selling all your Bitcoin and then buy them back, sell like 10%, and then if you are wrong, you didn't do too bad. But
Yeah.
if you're right, you're going to multiply your Bitcoin. So do
Mm-hmm.
things in a moderate fashion, with awareness, maybe make a plan. But you see, the entire idea is that, I don't know if it's an appropriate or PR. I don't know if your show is PR. Hopefully it's not. But it's like making love to a woman, right? Or a
Yeah.
woman making love to a man. You need to understand things. You need to
Yep.
understand what you're doing. And understand it's like here we are kind of almost making love to Bitcoin, right? We are trying to understand how Bitcoin works. We are trying to understand the cycles, the curves of Bitcoin. We are doing it at the right time. This is the peak. So if you study Bitcoin, when they say study Bitcoin, there is a component where you study the technology, we study the functionality, all the different properties of Bitcoin.
Yep.
But what about studying also how Bitcoin works, right? In terms of the price, in terms of the cycles, it gives you power that nobody else has, and you can use it for your own advantage, to multiply your holdings, and be more free, more earlier free than other people.
Earlier you had talked about frequencies, right? You were into studying the frequencies. Do you think Bitcoin has a frequency to it?
Yeah. So in fact, I did that. What is called a spectrum. I don't have it here, but you can actually do something more. Here, of course, the more evident frequency is this 4 years cycle, right? But there are more. In fact, I have a chart. I don't know if I have it here somewhere where I can start to. Let's see if I have it here. I have like tons of charts, but let's see if I find it.
Take your time.
I don't have it here, but I posted a few days ago. Well, I found a way of predicting like actually weekly cycles. So there are periodicity of it's not exactly a week, but it's in the range of a week where I see these very, very precise frequencies of Bitcoin, and I can use that if I wanted to actually sell. If I wanted to trade, but it's never too much of a good idea, because one thing is to do this long-term trend oscillations, and the other thing daily. But it's interesting where if one wanted to push it a little bit, where don't do too much, maybe a few $1,000 and play a little bit with these oscillations, you could do it. Like I can indicate that I have a graph. I just posted that, like I got a lot of likes. It looks like almost magic. Like I found these oscillations, and there are oscillations around the power law. So it looks like sometimes the price even locally follow the power laws when it dips. So you can use it maybe to buy the dips, for example. So there are these kind of like around a week type of oscillations.
And people that get paid once a month or buy once a month, they could time their buys based off of.
Exactly. In fact, what we are developing. So by the way, I want to tell everybody, I'm not trying to pitch myself, but
that's what I brought you on for. Do it.
And creating a community that is a Discord channel. So we have about 400 people right now, and more people are joining. So you're more than welcome to join us. And being part of a community, first of all, remember I say I'm creating this institute. So, you supporting. It's very cheap. We do it because I'm trying to do it as transparent and as open and as clean as possible, because I want to be a responsible Bitcoiner. I want to be respected in the community, even if some people push back or they misunderstand what I'm doing. But with $5 support, you're supporting this project. My son is making this video and is working full time, and I'm bringing other talents, and
it's
I have
a cup
this
of coffee.
These are people from Italy that are developing a DCA tool that is going to be automated at a certain point. So we are creating value, and we are adding all these things to the Discord channel. And if you come in, you get the indicators. I built this beautiful trading view indicator. You see here, you see this one where it has the the white line, which is the full model, the general trend.
No way, dude, that's sick. And those aren't cheap to build, guys. I know that. I've looked into trying to build my indicators.
Look at this bottom. This is a bottom, top. This is top, bottom, another bottom here. Look at the chart. Look how close and precise it is. And I have all these oscillations, and you can go all the way to when Bitcoin was born. Not when first exchanges, all the way to 10, and you can use replay. And you can actually pretend to be back in 2017. So we'll have a bot, using this chart.
Cool.
It's really amazing. And my son just made a video like today, in fact, how to use it, and people are really excited about this. But it even tells you, when we left the bull market, when we left the bear market, year, and then when we are going to the full bull market, and so on. It's really cool. And look at the COVID. This is again the COVID year around 2020, and you see how it was a week. It was just like one of these weeks, right? It was not even like a full bar. It was like a just for a moment went down that barrier there, almost like a iron barrier that you don't cross, and then it bounced back. And look at what happened in 2023. It bottomed there, and you see how it follows that bottom, almost perfectly. And right now the general trend is almost like a resistant level. It doesn't want to cross that place yet because we are far away. We just left the bear market. This is why it's too early for the price to go above the trend. It's going to happen during the full bull market. You see how it happened before when it went across, when it was the transition to full bull market. So, if it continues to do the same thing, it's too early. We got a little too excited because of ETF, and it's going to wait, and then it's going to repeat. So we have these, we give it to everybody that comes in the Discord. We have classes, we read this book, Scale. We have basically four meetings a week, where I'm there, we discuss as a group, and
where is that white line at right now? If it came back down like it did in 2020 and touched that white line, how low are we looking at?
We're 30,000, close to
30,000. Okay, cool.
Yeah. So that is like the minimum, and I think it will take something like COVID to go there, because you see, even the last cycle, we kind of left that white line. That is like in the previous cycle, I don't have it here, but if I could show you, in the previous cycles, it really followed that white line, almost like it was almost like scary. It was following that white line. But in the last cycle, something happened, maybe, some kind of exciting news, and the price, it kind of tended to be close to that white line, and then it left, and it started to stay like that. And then COVID kind of, cooled down the market, right? Say, okay, I need to go back to where I should be, and he went there to the white line, but it didn't go below.
Yeah,
sure didn't. It didn't cross that line. Like if something happens there where he says, I don't like to go below it, and then he jumped back and he continued. The triangle there is the halving, where the halving was supposed to be, and then the transition to full bull market happened, and it went crazy. The same way like we did like a double top, right? We had a double top because the historical top, if you look at this very precise periodicity, is supposed to be there. Usually it's around the end of a year. So, the cities where we are, it was probably November instead of in December. And so, but, the white line tells you more or less where the top is, when the price crosses that white line, it's time to sell. And also the deviations, right? The deviation helps you too. So it's more than one single signal. You're looking at 2 or 3 different signals. The price needs to be crossing that red deviation, that is a very large deviation from the trend. Then you have this cyclic kind of indicators that tells you, okay, we are close to 11. It's not quite 12, but it's 11. It's kind of very close to where we are supposed to reach the top. And then you have a white line that one way that you could do it could be, okay, it's crossing up. Then when it comes back and it crosses again with the white line, it's time to sell. It's time to sell. Maybe you can sell a little bit. Maybe you can do DCA down. It depends how aggressive you are. Some people want to maybe even to short, whatever. Depends on your style as a investor. If you want to be a little bit more conservative. Some people, even if you were a hodler, if you are saving money, save it. When you cross the blue line, don't buy in Bitcoin. Don't buy Bitcoin anymore. Or maybe buy a little bit, because we could always be wrong, and maybe Bitcoin start to go crazy and goes only up, and it doesn't do this oscillation. I think it's very unlikely, but you want to kind of hedge your bets, right? So don't buy 50%, and then as we come closer to the top, don't buy almost at all, and then save your money. Don't be tempted to spend it, and wait until we reach the bottom, because this model is very, very strong for the bottom. We almost never miss the bottoms because we have so many different signals converging, and the bottoms are much stronger in terms. So it's very good, because when you reach the bottom, sell your shares,
Mhm.
make a mortgage on your house, whatever, and buy
Yep.
Bitcoin, because that is the best time to do it. Don't go 100%, go 200%. And it's one of the most precise things of this model, and this helps you to tell you where to find these bottles. And then you can continue to do DCA, because it's good. And we are trying to do it automated, where at a certain point
Mhm.
you put maybe your keys, from your Coinbase or whatever it is. You don't want to keep too much money in the exchange, but as you get paid, maybe you can put $200, $300, and then the
Yep.
app will do that. And plus, we can use also these deeps, where maybe we find, okay, we got a deep, right? Because we are see how sometimes these deviation lines work. Like, look at some of them in different places.
Mhm.
Here, for example,
Support
look
and
almost like
resistance.
support and
Yep.
resistance, because
That's
even
it.
locally it follows the power law, and then you get the deep and say, okay, went down the trend, let's buy.
Yep.
It's a good deal. So better than just buying like randomly and doing DCA. You can do. We call it weighted. We call it power DCA. Because you use the power
Yeah.
law behind, so
Power
it's more
DC. I like
powerful.
that, man. I really like that. You should coin
Yeah, yeah,
that.
yeah. Right,
That's a good
right.
one.
And so we are really working hard, and we are almost there. We have like a channel in the Discord channel where we give right now our best suggestions. Every day we give, okay, 50% weight, 30% weight, and eventually we are doing a lot of back testing. Trying over and over again to find like a kind of optimal strategy. And we are almost there, and then eventually we are going to make it automated, so people don't have to worry about it.
Sweet. That's awesome. Well, I'm going to sign up, and I want to leave that link for everybody down
Uh,
in the video. So will you send me to where they can sign up? And I'm
yeah,
going to put it. I'm
yeah,
going to
yeah.
pin it in the comments at the very bottom of the video for everybody.
Absolutely. And for you, everybody that interviews me gets like your honor guest in our Discord community. So we'll send you a free invite to the indicators. You don't have to join and pay. Just
No,
be a member of our community. That is good enough for us. Because you are good. Um,
no, it's a cup of coffee, my friend.
influencer.
It's $5. I greatly
It's up to
appreciate it,
you,
but
but
I would like to support. I would like to support, my friend.
thank
I
you,
hope
thank
everybody
you.
does too.
When
That's I think you're adding a lot of value to the community, and it's the least I could do
I
is five
appreciate it. I'm
bucks.
trying
It's
to,
no big deal.
to make this my full-time job, because
Yeah.
look, I could, and believe me, I did have people contact me from big firms, okay? And I
Yeah.
could do this with a big firm. I could have done this
Absolutely, you could. I know Grant Cardone would
secret,
hire you.
I could have published somewhere, and maybe even just contacted some big firm, do a pitch, and I'm sure somebody will have seen value and
Hmm.
give me like a little trading desk, doing this in secret and not sharing with the community. And that is not my style, because I
Yeah.
love the Bitcoin community. I want to share these. And that is the other thing that people tell me, what if everybody starts to do that? First of all, I'm going to tell you, not many people will do it, because there are, like with the adoption of Bitcoin, where it takes awareness to understand all this stuff. So
Yep.
we are going to still be a minority. And then my idea is that if more and more people start to do this, it's actually one of these self-reinforcing loops. It's going
Yeah,
to
I
make
see
it
exactly what you're
stronger
saying.
instead of being
Yep.
weaker. And really look at this. Look at you can almost think about COVID like something that tried to break this trend, right? It tried to break it. It started to go there, and then Bitcoin auto-corrected itself,
Hmm.
self-corrected. So you cannot fool Bitcoin. You cannot play games with Bitcoin. Bitcoin will
Hmm.
play games with you. So if
Yeah,
there is some silly person that is trying to push Bitcoin in a certain direction and make it do
he
something
did.
different, Bitcoin will teach a lesson to this person,
Sam
maybe temporarily.
Bankman-Fried. Think about that.
Yeah,
He had the
yeah,
full
exactly.
backing of the United States government, the CIA, as
Yeah,
many
yeah,
powerful players. I mean, he was the number one funder to the Democratic Party, and this man had all that power and did everything he could to destroy Bitcoin. And Bitcoin put him in prison. Bitcoin broke him.
yeah,
You don't
absolutely.
fuck around. I mean, it
Yeah, you
is
don't fuck around. And that is
unstoppable,
the
dude.
math. This is the math behind that. This is the
Yeah.
math behind that. It's like you have this basically like a cosmic thermostat, where you
Hmm.
go to out, too cold, too hot, and Bitcoin say, no, fuck you, I'm going to bring it back. Other things like the numerals, right? When people started to push the system and started to make it crazy thing, well, there is the self-adjusting mechanism or difficulty adjustment where they get all these crazy fees, and at a certain point people stop, because they will lose a lot of money. They can do it temporarily, but Bitcoin is going to self-heal itself, and it's not going to allow any Bank Friedman or any other guy, or even Saylor, when Saylor say, oh, what if 10 of us are going to buy Bitcoin? Well, okay, you will make the price jump, but then Bitcoin will go back to its original trend. It's more the other way around, that as Bitcoin becomes stronger and more powerful and is ready to take in more billionaires, Saylor, think about Saylor, right? There was a time when Bitcoin was not ready for Saylor and Saylor was not ready for Bitcoin. What happened? At that time, Saylor was making fun of Bitcoin. Still it was, right? He was making, about that. He was actually saying, oh, Bitcoin is going the way of online gambling. It was very critical. And then Bitcoin turning over, and so Bitcoin was ready for Saylor, Saylor was ready for Bitcoin, and they joined together, right? And that will happen. Right now, same thing with the ETF. The people that now are praising Bitcoin, the CEO of BlackRock, he was talking bad about Bitcoin a few years ago. Now it's all converted. So it's this continuous cycle. This is the math behind that. If you play stupid with Bitcoin, Bitcoin will punish you. If you resist Bitcoin because you are not ready, or maybe Bitcoin is not ready for you because you're too big, you're an ETF, etc., it will take time. And if you are clever, like Saylor or even the CEO of BlackRock, it will join. You will become a Bitcoin. You will join. Maybe late, you get, like Saylor says, everybody gets the price. It gets the Bitcoin that they deserve.
Price you deserve.
And so that is what is happening. That Bitcoin is this black hole. That is becoming bigger and bigger and absorbing more and more stuff. And everything happens at the right time, at the right place. It's beautiful. It's beautiful. I don't know why people don't like. There are some people who resist this. I don't understand it.
I can't figure it out, man. It's like it represents so much freedom and so much prosperity and sovereignty for the human race as a whole. Even if you don't want to ever own any, like, you should still want it to win, because it's such a net positive for the entire world.
Exactly, right. And so, even if you think, okay, maybe it can go to the power of 8 instead of 6, why? It's good enough. Come on, 64 times in 15 years. So we never had an asset like that in all the history of mankind. That gives you 64 times, and secure, being solid, being of the system.
I think they nuked us. Giovanni, I don't know if you can hear me. It looks like you're froze up there on my end. I don't know if you can hear me. I don't think you can hear me, my friend. Well, I guess that means we're gonna wrap things up. I was getting kind of tired there towards the end. We've been going for 3 hours. What a great conversation, folks. If you guys get time, please swing over and follow Giovanni over on X. Where did I put his Twitter at? I know I had it. Here it is. There it is, folks. I'll give him a second to come back. All right, swing over there. That is at GIOVANN 35084111. Swing over there and follow him. BTC_power law. Or BTC_power_law, and he goes /plan G. I like it. Thank you guys for joining us. This is a great episode. Do me a huge favor, smash that like button. Please share this content with your friends and tell them to go stack some sats and help us save humanity. God bless you guys. God bless America. We'll catch you guys in the next one. Peace.
Run.